Right, let's try this again. See if it works this time. And my cat's just come in and started meowing. Of course she has. Impeccable timing. So, power's back on. Unbelievable. So, we could try and carry on where we left off. So, Sven's here, Ian. Who else is here? Not many, I think only 4 people are viewing right now. Hi, Jim's here. How's it going, Jim? And Shin Lun. How's it going? Right, so we can try and actually get some stuff. I don't know how this time of day is going to go for streaming and reliability and that sort of stuff. Usually my internet connection is not very good at this time of day. I've done a speed test and it was about a third to a quarter of its normal speed. We'll see how it goes. But I haven't dropped any frames yet, so that's a bonus. So it's looking like it's maybe going to manage. Fingers crossed anyway. So hopefully the power stays on this time. Anyway, give people a chance to get here and we'll start digging into things. So we've got the Keithley 150B, which we need to work on, as we discussed this morning, and also the HP 3406A, which is what won the poll this morning as well. Gotta go sleep. Yeah, good on you. I've not sleep. Maybe I should have done, actually. We'll see how we go. See how late we end up going. Because it is 8 PM here now. Getting close to bedtime. Joking, obviously. I'm a nighttime person. So anyway, so we've got a couple of things we're going to tinker with. And we may even look at some other things. Something else that's occurred to me is this device right here. This is my name's gone off the top of my head. Valhalla 2500 EP current calibrator. I did a video on that before, and the unit I think might have a problem still, or I created a problem because I'm pretty sure I overloaded the input on it once, and it may have damaged one of the protection diodes. I'm not sure. Works fine on DC, put on AC, not so happy. So I think I need to look at that as well, but I don't know if I'm going to do it today. It's something that just occurred to me a little while ago that I should probably look at that one. And as it's now evening, I decided I'm going to have a Corona. Just for a change. What's wrong with doing electronics around high voltages and drinking beer at the same time? What could possibly go wrong? Yes, anyway. So, we'll see how the stream goes, whether it's going to be a problem or not. Power outage that lasted about 2 hours. Just under 2 hours, probably. Yeah. I mean, yeah. Anyway, we'll see how we go. We'll tinker with some stuff and we'll see how it goes. I just need to get a opener. Because, you know. And as we don't want to promote drinking on YouTube, oh, too much. Now wet myself. Tissues. Right. Okay, that went well. It's fine, it's coffee. Anyway, so we'll play with some gear and we'll do the thing I planned to do this morning, which was this Keithley, and then we'll go from there and see how far we get. Yes. stop joking around. Let's actually do something serious. Mixing a coffee, it could be, I don't know. Right. So one other thing I was thinking about this Keithley as well, something I've been meaning to do for a while, which I keep forgetting about, is that the built-in filter in there, it's got a filter for filtering out 60 Hertz mains noise to try and get more, well, cleaner readings. Now the problem is that New Zealand's 50 Hertz, not 60. And I've had a look at it, and there is actually options in there for 50 or 60 Hertz from the factory, so it can be configured either way. Hey Rob. So the filter could be 50 or 60 Hertz, but I've had a look at it and it is set up for 60 Hertz. Now I'm going to show you on the screen up top here what I'm talking about, and I'm contemplating changing it so it will be a 50 Hertz filter, but I'm going to need to order some parts for that, so I won't be doing much today. I mean, I could do a little bit probably, but probably not the whole thing. Let's go to the top screen and we'll show you what I'm talking about. Once I go to figure out which one it is, this one here. So this is the circuit diagram for it. Right, you've got two diagrams. You've got one for the power supply, which you can ignore. Well, kind of ignore. You're going to be working on this as well. I'll show you this bit first, actually, before I get sidetracked. So what we're going to do is the battery, and there's the battery there, and there's the fuse, which is on the negative side of the battery. So this is something we need to hook up. This shouldn't take too long to the battery side of it. Which is why I'm thinking this won't be much of a job to do this Keithley, but I do want to do a video on it. So the battery there, 6-volt battery. I want to measure, see what voltage is actually coming in here, and see what it's trying to charge at and that sort of stuff. It's got a 3/4 amp fuse, which is great, but I actually want to see what voltage is there, and maybe see what charge current is there too, just to see what it's trying to do with those batteries. Because I'm not using NiCads anymore. I'll be using nickel metal hydride. Same voltages, kind of, but slightly different. And the other bit we're going to look at, if I can get the right screen, is the filter here, which is what I'm wanting to change, but I don't think I can do it now. But I'll explain it to you anyway. So this is the filter. So normally there's a little switch on the front panel. You turn it on, which is here. Right. So when it's out, it's disabled. So this is the negative side. So basically it grounds this side here when you turn that filter on. So it pulls that negative side of the capacitor and that resistor to 0 volts. And in here we've got these values here. This one, and this one are selected based on the frequency you're trying to filter out. And this is the trimmer to allow you to fine tune it. Okay, so obviously what it's trying to do here is when you turn it on, it straps this capacitor across the junction of these resistors, and to 0 volts, and it also puts this resistor across these capacitors, pulled to 0 volts. Right, so it's RC filtering, but it's got like a dual filter system here going on at the same time. But these resistor values need to be changed. So these are stated as being the 60 Hertz filters. 50 Hertz, these are 1273, right? That's the resistance in ohms. So 1.273k is what these are. These are precision resistors as well. These are like 0.25% low. Name's got in my head. Change my thermal. I've got my names now. I've got the word's gone. Anyway, precision resistors anyway. And this one here is just a standard resistor. There's nothing special about this. It's like I think it's like a 5 or 10% resistor. I think it's 10% resistor, this one here, and it's in 50 Hertz. It's only a 1k 10% resistor. Nothing special. Carbon composite. Nothing particularly special about that one. So these are the ones which are tricky. Temperature coefficient, yeah, I suppose. Yes. That would be it. So yes, that's what I'd like to change, but so I don't have these other resistors here yet. Now this is also on that input board, which is the one which uses the cadmium solder, I believe. And these are on standoff posts, so these can be changed without taking the board out. But this one can't be. You have to take the board out to get this one out, which is annoying. So that's one which I can change easily because I've got the part, but I've got to take the board out to do it, which means disturbing it all. So I'm going to wait until I get these other parts in. I will get these in at some point, and then I'll probably revisit it and change this to 50 Hertz. Yeah, but that's that part. But right now, we want to look at doing the battery. So the original battery, let's look at the layouts. Where is it? This one here. So the battery connector is in here. There's a little block on the side. Let's make it slightly bigger. Alright, so there's a block on the side which is where the battery connects to. You can just see the wires snaking around here. And there's the original battery pack which would sit in here behind that plate. Okay, there's a gap in there. Now, that's quite a large battery. What I'm going to be putting in is a fraction of the size of this. But my intention is to double-side tape it to the side here. So it's got the connections right here, and stick some double-side tape on and shove it right here. Just on the side of the chassis. Should be fine. That's the plan I've got anyway. It may not work, it may work. We'll find out. But I need to do some measurements first. I want to see what voltage there. I want to measure these posts, see what voltage we're getting, and maybe try and measure the charge current by having one lead hooked up, and then measure through a multimeter to see what the charging current is on those batteries, just to see how it's actually performing, just so I know whether it's going to be potentially overcharging it or whatever. But this isn't something that's going to be on all the time. Hey Dave. So this is something I'm going to use rarely, which is why I'm going to put nickel metal hydrides in there, because they seem to last really well. Other things like power tools I've had which have got nickel metal hydride batteries in them, they've been brilliant. They've lasted for years and years. I mean, I've got a little Dremel, battery powered Dremel, and that's got an IMH batteries in it. I've had that thing for about 15 years and it's still like new. It's incredible. So that's why I chose those particular batteries, and because the battery voltages are basically the same. If you try to do lithium or something instead, you have issues with battery discharge, and obviously you've got to pick safe battery levels and stuff like that, and you've got to keep them topped up a little bit because they do have a bit of discharge rate there, and the voltages are different, so it'd be harder to get a 6-volt battery pack in lithium. You'd have to do a conversion with a buck converter or something, or step up even. So yeah, that's why I want to do nickel metal hydride. So it should be a pretty straightforward thing. I was tempted to do the calibration on this as well tonight, but I think it's probably best I don't, because it does require the thing to be on for a period of time for stabilisation, and it's got to warm up for a period of time and that sort of stuff. And there's a bit of fiddling around, and I'm drinking coffee, and you know how that could go. So we'll just do the simple thing first, and we'll probably play with something else after that. Looks like the filter's a wee bandpass filter. It could be, yeah. Well, I think it's probably going to be a notch filter. Be the inverse of that, it'd be a notch filter, because it's supposed to cut out. Where's the diagram gone? Gone past it. Oh, I've lost the diagram. There it is. Because it's supposed to filter out 60 Hertz in this case, or 50 Hertz, depending on how it's configured, like the actual values, as I said. So I believe it's actually configured as a notch filter rather than a band pass. It's probably like high pass, low pass configuration, so it performs a notch. Notch, yeah. So, hey, we know what you mean. It's all right. So yeah, that's something I'd like to do. I mean, I could do half this conversion, but I'm not quite sure how that would affect the filter. I mean, is it best to leave it running at 60 Hertz, or is it best to half convert it and maybe have a wider notch? Or I don't know, is that going to be something weird? I don't know. I'm also wondering if, because this is changing these two resistors here, well, is this basically being an RC filter using this big capacity here? So 5 microfarad capacitor. I mean, could the other way be changing that capacitor instead of changing these resistors? I would have thought that would have been a method as well, but I don't know. Potentially. So yeah. Anyway, we'll have a tinker around with this. We'll get things working over here. Hopefully the power stays on this time, and we'll get started. Get some lights on and change views. Let's do that one for now. I've changed my power supply setup over here. I used to have these overhead lights done on a brick power supply, those little switch mode bricks. I'm trying to get the bench area quieter to reduce the noise and things like the scope and what have you. And I decided to revamp my desk a little bit here as well, my bench area, where I've got these undershelf lights now, under here and here. I've put those in. So I always had one under here, but I didn't actually tend to use it. Was it under this one? No, it was under this one here, sorry. But because of the noise your power supply is using, because there's a switch mode, it's a really good little supply. It worked quite nicely, but it was a bit noisy because it's switch mode. Even though I put extra filtering and stuff like that in it, it just wasn't good enough. So I didn't tend to use it. So now I've got these LED strips under this shelf, and that's running off the Siglent power supply over here, which is very low noise because it's linear. It's a linear power supply. I've had this thing sitting here for years, and I've only used it probably half a dozen times in all that time. I got it because I liked the supply. It looked like it's quite good. It could do up to 8 amps, which this Core one can only do 5 per channel. Of course, you can always link channels together, but sometimes you want something a bit different, and this can also do logging, and you can use an app on this, or like the Siglent Easy Power app, I think it is, for Windows, and you also I think it's got web server on this one. I think it has, but you can do that sort of stuff, and you can trace it and control it remotely and things like that. I actually did I did a control definition for this thing in Test Controller. I think I wrote that one. I'm pretty sure I did. So you can actually control this in Test Controller as well and get readback from that. So, but now I've got this reconfigured to run my lighting system here. So I've got nice, quiet power supply for these lights, which is good. And I'm actually pretty sure that since I've changed to this, that my lights have got brighter. So maybe my brick was getting dragged down as well. It's possible it wasn't actually generating the high voltages, or maybe the cables weren't doing a particularly good job. I'm not sure. What I will need to do is get my tablet fired up so I can see what you guys are saying when I'm over here. Right, one more light, and also I want to record video on this. Need to bring my coffee over here. Also need to refill my coffee. Right, come on tablet, wake up. Let's get in there. And I'll chuck power on that too so it doesn't go flat when I'm using it. Well, that does last for ages, so I just like to keep it powered up when I'm using it, that's all. And the cat's come back in. What do you want, George? Right. So I need to hook up power to this and to that. Power cables here. This app has taken ages to come up. There we go. Takes a little while to boot up. Pause playback. Hey Adam. You missed last night. Well, there's nothing to miss, Adam, because I had a power cut and it didn't really get that far. Oh, that's right, this has got a different plug. This has got its own built-in plug instead of a IEC connector. But having a cable hanging out the back is a bit of a pain. It's tempted to put an IC connector in it. Maybe one with a filter built in. It's actually tempting. Is that something I should consider doing? Don't think there's really room for it. There's not really room there for it. I mean, it'd be close. It'd be a bit tight. Don't think I can get one in there. Power out now. I don't know. It was out for a while, nearly 2 hours. So I think a tree fell down or something like that. We've had a lot of rain around here recently, and the ground is really soft. Just been persistent rain, not particularly heavy, just persistent. There's been lots of it, and the ground is just really sodden. So I think a tree fell over. There's a few trees down the roads on the way here, and they've been on a lean for a while. And each time it rains, they seem to lean slightly further. And there's one massive one which is sort of leaning towards power lines. I'm guessing that one fell down. I don't know. But normally here we get a power outage. It's only for like 5 or 10 minutes, and it's back on again. But yeah, usually when you get a big outage like that, it's because the tree's fallen over. Right, so we've got powered out. I'm not going to hook up the input cable yet. I just want to measure here to see what we're getting. And I need to make sure I don't forget to record video, because I'm almost forgetting to do that. This will be my coffee. And I'll probably change views to the camera view so you can see what should be a better shot. Actually, it should be a better shot. Thanks, Sven. Alright, HDMI. That's a much better shot, isn't it? It will be once I get set up. Yeah, put my coffee back over here, I think. It looks like coffee, doesn't it? Maybe, I don't know. Right, let's record some video as well. I should grab a screenshot to do this before I forget. Always forget to take thumbnail shots, always. Right. So, next part of the repair series on this thing, and we're just going to do some basic stuff on this one today. It is basically working, it does seem to be functional. Calibration's very slightly out. I'm not sure if there's something wrong with the meter actually, because looking at the needle, every time I look at it, I think it looks wonky. And if I look at it straight on, I don't know if you can see it on camera or not, if I get close enough. Can you see that one side of the needle was on one side of the zero, and the other side is kind of on the other side. Right, so it looks like the needle might be slightly bent. Like if I get that lined up so on camera it's smack on the bottom zero, like that, you see it's to the left of the top zero. So I actually think this needle might be slightly bent. And even when it's not, you know, weird, it's just, I don't know, it just looks like it's off to the left. It always looks that way. Every time I look at it, it looks like it's leaning to the left slightly. I don't know if it's just like imagination or what, but it just seems like it is. I need like a little square to check this, but, you know, stick this, is that enough? Kind of. That's not really square enough, is it? So we can get a square which will line up. Try and see if it is actually wonky or not. It's not a great way of doing it. I really need a square, it's too wobbly. Just have a look. It's kind of pushed onto the desk. I don't know, can't really see. I'm pretty sure the top of that needle is bending over. See? Yeah. That needle is very slightly bent. Also, I think it should be about there, not over here. I think it's very slightly off to the left as well. It's a bit weird. No, this coffee's far better than your one you had. Right. So what I want to do now is actually look at doing a battery pack. So this originally has a battery pack in it. You know, this is how they're designed to run. The battery function here. So you have that, you'd be running off battery, and there you'd be running off AC. Off would normally be charging the battery, and if you need to check the battery status, you can push it over there, and it should give you an indication on the screen, or on the meter here, saying what the battery level actually is. I've got no idea how that actually reacts. No idea. Now, this battery pack that was supposed to be in this thing originally, long gone, who knows where. Probably a good thing. Good chance it'd be leaking everywhere by now, because this thing is made in the 60s. So, I've got a nickel metal hydride battery here, NIMH, and this is rated for 2.1 amp hours, 6 volts. Now this is supposed to be a 6 volt battery in here, as original, so it's the same voltage rating. But I want to measure on the side here these terminals, so you can just see down there. Right, that's where the connections go for the battery on this side. So there's actually a standoff mount here with terminals you screw the battery terminals onto. Right, the battery is normally mounted down here. What I actually want to do is mount this down there. Right, double side tape it to the side. These wires can go straight to those terminals, all fairly compact, easy to access, that sort of stuff. But first I want to measure the voltages here to make sure that they're not excessive, in case there's something a bit much going on there as far as voltages for this. Just in case I need to take some precautions about overcharging these things. This, at least when I own this, it's not going to be getting used that much. It's mostly going to be put in storage and just used occasionally, and you know, when I need to put it out to some precision measurements, it'll be used for that. Which is why it needs to have the battery pack in it, because this needs to be used for the low levels. But I need to make some precautionary measurements first. When I see what the voltage is here, then I'll get this thing half hooked up, then I'll check the current as well, see what charge current it's using, and we'll just go from there, just in case I need to change something to control this. I might need a charge controller or something on it, it's possible. I'm hoping not. I'm hoping I'll slap this thing in it and work, because in theory it's the same voltage and it should be very similar to original batteries. Hopefully. Camera indicators on, yeah, well you will see something. I'll turn this off for you, there you go, I'll make it a bit easier. Is that better? Breakfast, no worries, Dave. Right. So, first things first, need to measure that. Right, let's see what we're going to get. It's going to power onto it. It's currently in off state, but that shouldn't matter because this should be powered when it's off anyway. So I think the bottom one might be negative, I don't know, we'll find out. 24 volts. Well, that's a bit more than 6, isn't it? Wow. That's curious. If it's trying to charge up to 24 volts, that could be a problem. Why is it 24? Let's turn the power on, see if anything changes. $25, it gets worse. Okay. That might change things a little bit. Why is the voltage so high? Maybe I need to get a different meter and try something else. Why would I have a 25 volt winding on the bloody transformer when it's to charge a 6 volt battery? That seems a bit ridiculous, doesn't it? AC. Low Z AC. Bugger. Well, that does show volts DC as well. Maybe it'll work. Let's try it. Still 23 volts, but also getting 11 volts AC there. That's not good, is it? 11 volts AC, 24 volts DC. This power supply doesn't seem particularly good, does it? I didn't record that, probably should have done. So I've got my Fluke 289 here, low Z mode, but it's got low Z on AC, but this does an AC and DC readout. Let's just try and make this a bit easier, just for you to see it. Now shove this in here. 11 volts AC, 23.4 volts DC with a low Z option. That's a lot more than 6 volts. What's going on there? Well, that changes my plan slightly. This was just going to be a simple drop it in and go thing. Why is that different? Might need some more coffee. Right, back to the power supply. Let's have a look up here. What's going on this? Why is this doing what it's doing? That is not what I expect. So there's no capacitors in here, so that explains why the AC ripple is quite bad. It's just got the diodes half bridge rectified. So it's relying on the battery to act like a capacitor. Yeah, that's not best either, is it? I should probably do something about that. Interesting. Well, there's no regulation really, it's just purely from these two diodes. So whether this winding voltages, and it's just obviously there's no smoothing, there's no capacitors or anything in here. It's got a current limiting resistor here, 56 ohms. Oh, you can't see what I'm talking about. Yeah, do this. There we go. And get into the right screen again. Right, so there you go. There's two diodes up there. Current limiting resistor, 56 ohms. So there's the power switch. Right, so in state 1, which is AC mode, it's on. Off, that is on as well. So it's off or running, it's charging the battery. If you're in battery mode, it's not trying to connect to the coil or the transformer, and it's only running for battery only down here. That's right, East Power. I'm back. And my coffee tastes a lot better. Just saying. No, I'm not talking about UPS now. I'm talking about the thing I actually went to do this morning, which is the Keithley, and putting a battery in it. But we've discovered something interesting. The voltage I'm getting here are way higher than I thought they should be. So if I stick a battery across this, you've got a 56 ohm current limiting resistor. I'm thinking I should chuck a voltage regulator in this. Yes, it is configured for 240 volt. There's a switch on the back, which is indeed configured for 240. So it's in this position over here. Yes, it should be. Should I double check it? Just in case. $234 is marked as. That's what I'm seeing there. So, yeah. So obviously that's the 117 volt side, that's the 234 volt side. That's fine. So that is definitely correct. Just in case it got moved, I don't know, something happened, but yeah. So the voltage is way higher than I want it to be to charge our battery. Now to know what this battery voltage is, you have a battery check function, which is this A here, comes over. So if we ignore the running circuitry and we come down to this circuitry over here where the meter is, A comes in over here, goes for another resistor, and that's then one of the switch positions is there for the meter. So as you change the meter around to the battery test mode, it actually hooks it up to this resistor and you can see what the battery voltage is. I don't know how it actually rectifies on the meter itself, whether it actually, don't know what scale it actually uses, no idea, but that's where that goes. And this section here is actually using the battery. So when you switch positions over here, so you've got AC off, battery and battery test, this will point to these two. So this is the circuit which is then powering it, coming down here. Right. So if tricky thing with this is the positive side going to there. This is a negative rail. It's a low side. Which is the interesting part there. It's got a common positive, not common negative. So it's tied to that. Which makes it a bit interesting. Potentially. Because it means I need to use a negative regulator. And not get completely confused. When did the power restore? It took nearly 2 hours. It was out for almost 2 hours. So, yeah, this is what I'm thinking now. Is I need to potentially do something here to regulate the voltage to the battery from the charger only. Well, Ian, the voltage I measured on the terminals should be after the diodes, right? Because that was where the battery connections are. So that should have been here and here, right? Where the battery terminals are. That's what I measured. Was there. So that should have been effectively after those diodes, which is why I was getting AC ripple there. If I had the scope hooked up instead, you would obviously see ripple. You know, the half sine ripple. Mains AC side. You mean this one here? You're thinking about potentially tapping off that one instead? Is that what you're thinking? So it goes to the same positive feed. Negative side goes to the switch. And goes down here as well. Yeah, I think I should probably find that point there, that green wire from the transformer, which appears to go to the switch there, and we'll see what voltage we get there, I suppose, just in case it's been swapped over. But that's red with red white and red there. I did see a red white in the area, so yeah, I think I did see one. Let's have a look again. Let's turn the power off. I was at myself. There's a brown and white, and yeah, two brown and whites there. They go into the positive. Transformer, there's the greens there. red, white there. It could be that side, maybe it's the other side. Anyway, there's the switch. So what we could probably look at is trying to find a wire that makes sense on a switch. So in the on state, which is this one, that's connecting this wire here. And my tablet's just quit itself, so I can't see YouTube anymore. Come on. Come on, open up. Why does YouTube quit itself? Oh, for God's sake, I can't see the chat now, YouTube's not working. Whatever. Okay. So the green one there is the common. Didn't I say green was a common? Was that right? No, green was the switch position, wasn't it? Wasn't the common. Obviously rubber duck's too big, Alan. Yeah. Let's look at this. Hey, Kiri. Alright, so this is curious. There's a green wire going to the wiper of that switch position. Trying to make sense of the actual switches. I'm sure there's like a diagram that shows it as well. That's on there. That's on there. I don't think it's that wafer. I think it's a different wafer. I think it's the front wafer. I could be wrong. Might just probe around and see what we find, eh? I can't really make sense of that right now. It comes through the bottom here. Not sure. Some markings down there. Come on, YouTube app, can I work? There we go, that's going to work. Stop playing. Hey, Q's. Yeah, what's to say? It's a microvolt ammeter, so it can measure voltages and currents below 1 volt and 1 milliamp, or 1 microamp, 1000 microamp, so 1 milliamp. So very low currents. Go down to nanoamps. Nanoamps is the nanoamps is the lowest it can go down to. 0.3 nanoamps and 0.3 microvolts is the lowest it can do full scale. So this is meant for doing precision, low voltage and low current stuff, which is why it's got this really beefy weird connector on it. But right now I'm trying to figure out how to put this battery pack in, which is what I want to do. But those voltages are just way out from what I thought they should be. Anyway, Actually, I might carry on using the Fluke because, well, the Fluke, the big Fluke, because at least I can see AC and DC at the same time, which could be handy. I'll carry on using this. I'm actually going to peel the screen off because this is just getting in the way. I don't normally like to take these off, but let's do it anyway. How old is it? This is built in the 60s. About 1967 or so. It's older than me. Let's do... actually, no, that's not right. AC and DC. I want both ranges. Here we go. So, turn the power back on. And you've all gone blind. Right, we're back. Well, the only reason I've got these Fluke meters is because they gave them to me. I did reviews on them, so that's why I've got them. Otherwise, I doubt I would have bought them either, because for the same reason they're expensive. Let's measure there and have it in the off position. There's that same voltage there. Curious. It's looking more reasonable in that position. That's on the red wire. I'll take it to the other side. I've got a chassis ground. What's coming to the chassis ground? Let's look at that. 12 volts. I'm not quite sure which reference I should be using for this. Interesting. Yeah, it's just curious. Well, it's a bit slow probably because I'm doing dual readings. I'm doing DC and AC at the same time for a start. I think there are settings in the back that actually slow to speed it up. There are some settings in there. You can adjust it, but it hasn't bothered me. I think you can do like 1 digit less resolution and get a faster update rate, like 10 times faster or something. But anyway, okay. You need to think logically about this. I've lost the plot. Let's go back and have a look. So back to this. Might need some more coffee at this rate. See, that switch has got multiple connections on it. So you've got S201 here. Those two connect together. So off and AC are connected there and disconnected there. So let's find the other S201 connections and just try and make sense of what they actually are. I don't think there's anything else in that diagram. I think it's just down here. I think it's just here. So there's 3 wafers, or double-sided wafers. So there's 2 of them. Don't think there's anything else. Just looking. There's a function controls. This 102, this 103. Okay, yes, yeah, so it's only got 3 sides of that wafer. So one side's doing this. So I'm trying to make sense of which one's which. Wild colours here been handy. Thanks, Keys. I think I'm that smart. If I was smart, I wouldn't be struggling with this right now. Right. This is just the battery system. I mean, why can't I figure these wires out? Okay, so I need to look at these switches and actually figure out which wafer is which one, because it's not particularly clear. Because it doesn't say like wafer A or wafer B or whatever. If it did, it'd be a bit easy to understand. Okay, later. Adam, catch you later. So if it actually had the wafers marked, it'd be a bit easier. So I've got to try and decipher what the switches are doing and figure out which wafer is which. So one wafer has got those two on, so AC and off are joined together, and the other two positions have got nothing on them. Let me try and figure out which wafer that is. And you can't see me. Right. So let's turn the power back off again for a minute while I'm messing with this. So AC and off is those two. So those connections. It's not those connections, so it eliminates this back wafer. That leaves to those three. So this green one here, which you guys can't see right now, I'm trying to get so you can see. It's nice, right? But looking at the floor, not quite right. So that green one there is the wiper of that switch. That's always on, right? So that's going to AC. That is going to the next one over. So that is not the same. When I go to battery, it joins this one and this one together. So AC and battery are joined together. So that's AC and battery there. So that might be the battery side. Let me have a look. Battery test. No, that doesn't really make sense. The battery test is over there. And there's a resistor. So that must be the meter one. That one there must be for the meter. So it must be over here. So there's the wiper there, which is this one, which is a red wire, I think. It's a white wire with a black stripe on it. So that's on, goes to that one. Off is disconnected from that one. But it's also got other connections down the bottom. I think. Does it? No, it doesn't. There's another wiper over this side. Might be those ones. Two linked together down there. Yeah, I'm actually not looking at this as quadrants, there's actually quadrants on this. So each one of these is a double pole switch on each side. Didn't notice that before. Okay, but it's not that side. Might be these ones down here. Because those two are joined together when it's in on position and off position. When it's in the battery position, they're disconnected from each other. When it's in test position, it disconnects it as well. Not sure, considering that one. I don't know, I'm having trouble figuring this one out. Connection should be right. I've already cleaned the switch when I looked at this before. And there weren't any evident connections anyway with problems with that, but I cleaned it anyway just to be sure. But I'm just trying to figure out which connection is which, because unfortunately it's not clear. Where's the wiper on that one? Yeah, each one's got two sections to it. This one's got another section there as well. Oh, this is a pain. Why am I looking at this again, Ian? Where is it? I'm trying to see now. Well, you can't be able to see what I'm looking at. Should be able to figure it out. It's just a bloody switch, for God's sake. Yeah, okay. So it's only got three sides. The front wafer here doesn't have a connection on that side of it. It's only on the back. So there's 6 possible connection setups on there. There's 6 separate switch sections, I should say. And it's obviously got those wired together to create a different switch arrangement. But there's the 100k resistor right there. So that is how much goes to the meter. And there's those ones joined together there. Those three there joined together. So that is on in that changes that one over from one side to the other to the switch of that switch. Oh, that's so hard to see what's going on. Why am I in trouble with this? Those two join together when it's either on or off. Those two there join together, right? And on the opposite side of the switch, it's the same arrangement on the two red ones. So if the black ones are joined together, the red ones are joined together. Can you make sense of that? So one of those connections has to be this side. But those ones there don't go together. So I think it's that one there. AC and off are separate here. But AC and off here are joined together. So it might be this section here, maybe. Then that's 3 connections. It's not doing that. And there's the 100k there, right? Down there. It'd be so much easier if I marked them A, B, C, D. It would have been so much easier. Oh, yeah. I was thinking of doing a battery on this would be easy. And there's a green wire supposed to go to that switch section there. But I'm seeing a green wire on a common. And that wire there, that A wire, or the A connection, it doesn't actually say what that wire colour is. I don't know if there's anything in these layouts. Probably not. I doubt there's anything in here which is going to tell us anything. That's R228 sitting down there. That's R152, which we know about, I think, anyway. 100k. G. It's got G there. Yeah, well, what Ian was suggesting I look at, I think, is the actual other side where the normal AC comes in. So, this bit we already know where these are, right? That's those terminals on the side. We already know what those are. What Ian, I think, was looking at was this side. And see what voltage we've got here. If I find... Oh, that's not going to tell me, is it? I've got to find a green wire that goes to this position here. It's supposed to be a green wire. Maybe it's only green on one end. And that's why I can't find it with a switch. It could be green from the transformer going to the circuit board, and then the circuit board goes out to the switch. Possible. So in the AC position, there should be a green wire, but I'm only seeing a green wire on a common, which goes to Q218, which also comes back to that capacitor there. Assuming that's the green wire there, it may not be that one. So I'm pretty sure one of those pairs is this one. So there's a black and a red pair which should go together. But that's what I looked at, Rob. The terminal voltages were quite high. They were way above 6 volts. I was getting 25 volts DC and about 11 volts AC, because there's no capacitor smoothing in here. It's purely diode, so it's obviously relying on a battery to act like a capacitor to smooth it out. So it's going to be, you know, still quite high. Still way more than 6 volts. So I think it's going to be excessive. Because that's half rectified. Let me just think about something. If that's smoothed, I think that's about nearly 8 volts. 8 volts charging. About 7.8 volts once it's smoothed out. I think I've got that right. Is that going to be an issue? Should I stick a capacitor across it and see what happens? See what voltage you get. But it's smoothed out. That could be an idea, eh? Let's try that. Yeah, how am I going to do this? I'm going to clip these leads on. Might be able to. And work a decent sized capacitor across it. And 25 volt, maybe got a bit different. Let's get one of these ones here. Decent sized capacitor across it. Which way is which? The negative is actually on the top side, I think. If I get this backwards, what's going to happen? What could possibly go wrong? Right, so if I can probe this and turn it on at the same time, then we can get the probes to sort of sit in here and just gain contact, you reckon? Maybe that'll work. Getting the wedge in there. Sure, I could have done a better way, but this might just work. Maybe it will, I don't know, we'll find out. Turn the power on. Working. Okay, change it over. Kill one. No, I'm be fussy about it. No, that's actually worse. That's 37 volts DC. That's worse than I was thinking. That must have gone the wrong way. Okay. That seems kind of excessive for a 6 volt battery, doesn't it? 37 volts. That's definitely interesting. Let me try something else. I just find it weird it's that high from original. That just doesn't seem right. Put the 235 out because this one has got a low Z mode. Yes, even that's only dragging down to 34 or so. Yeah, 33.7. That didn't help much. I was thinking maybe a bit more loading might help, but apparently not. What's going on there? Well, the weird thing is it used to have a 6 volt battery in it. That's what it's designed for. That's what I'm not getting. Why is that so far out? That just doesn't make sense to me. Why is it that different? This is supposed to be an easy modification. It was supposed to be easy. I thought I'll just chuck this in, take 5 minutes, and we'll move on to something more complicated. Wow, was I wrong? That's weird. I'm sure I'm missing something here. This just does not seem right. Or has someone done something weird in the past and messed it up? I wonder what these diodes are. If I can measure these diodes, if I measure from this side of these diodes here, like the junction of these two, and the junction of those two, because that's joined together, I can double check to make sure it's not some weird connection that's here which is wrong. Shorted secondary winding? It's possible. I mean, anything's possible right now. I mean, it's got a resistor here to drop the voltage down, but if this is a 6-volt circuit, right? It definitely says 6 volts here. Why would they design it with such a high voltage here to have to drop it down with that resistor? That just doesn't seem to make sense. That can't be right. I mean, if there's something, maybe someone's changed the wiring configuration or something, and it's not right, or there's a short somewhere and it's missing this connection up. I mean, if I go straight from here to here, because that's connected to there, that'll tell me the winding, or the voltage across the diodes. I mean, I could even get something similar, couldn't I? That's the battery. That's the voltage the battery should be seeing if we go from those junctions. Obviously, excluding the drop from that resistor. Yeah, I'm going to check that. So 207, 208, 209, 210. We've got to find those. They're probably on the main board somewhere. Two 207, 208 are down here on the switch apparently. Oh, really? Okay. That might give us a clue about how the wires go to that switch as well. Where's the other ones? Where are the other two diodes? We've got 209, 210, haven't we? Those are 100 series. Where are they? There they are on the main board. Down here. There's 209, there's 210. Right, so I have to flip it upside down and look at those ones. Well, this could be tricky, trying to measure between those. Right, might require a bit of thinking about this. I'm getting them from the bottom, it's just trying to get through these and the other ones at the same time. It looks like the right hand side is one that's joined. Hey, yeah, the yes, I did the low Z mode on the multimeter 4 to try and load it down. I'm not sure what size resistor was in it. I've forgotten what size it is, but that should have loaded down a little bit. 1K maybe. I mean, putting a capacitor on actually increased the voltage. It's getting the peak voltage more. Even 37 volts, that's excessive from peak. I mean, I don't know. Just suspicious something's not right here somewhere. Shouldn't have been this tricky. Yeah, that side is joined together just there. So yes, I need to measure from that side there. Right. Where's that other one gone? Lost it. In there somewhere. It's inside there somewhere. Right, let's have a closer look at this. Let's record some video. So I'm still trying to track down why its voltage is a bit weird. So I've put a capacitor across this connection here to try and smooth it out, to add to a bit like a bit of a load and help smooth out the AC, because it's got a half rectified AC there. So adding a capacitor will smooth it out and give us a better DC representation. I'm getting sort of 37 volts unloaded. I'll put some loading on it and get down to like 34. But that's still a long way away from the 6 volts, or just above 6 volts I was expecting. So still digging into this. Something is a bit weird. I don't know what that is yet, but something's a bit weird. So you can see those diodes down there, and you can see those diodes there. I might be able to get them both. So I'll do the drill readout again. So that's one side of those diodes, and I'll get my fingers in here without touching anything I shouldn't. Come on. 37 volts, yeah, so that's what I was seeing on that connector. So the wiring looks like it matches. Okay, well, let's try something different. You can't see it too well there, can you? Just check the diodes. That's in capacitance mode. That's not right. Diode mode. I'm not sure. Was it? This was a bit slow to come up, wasn't it? Come on. Is that going to give me anything? Getting nothing there. Come on, let's go on here. Having trouble getting onto this angle. Why is that beeping? Without showing a short, saying overload. That way is nothing. Even that's been weird. Let's get another meter. Oh dear. Diode mode. And that's doing exactly the same. What the hell? Power is off. Is it this capacitor is charging? Could be that, I wonder. Yes, that. This capacitor is charging. Okay, that's those diodes that are like. Okay, that way. My string of centers together would be great. Those are right that way. That's good. That's good. Well, those diodes are fine. Nothing with them. It just doesn't make sense. Why would they have such a high voltage on there? That's weird. I know. Doesn't call it Chinese ones. That's what it is. Those Probemaster ones here, those are gifted to me by Joey, who was a supporter at the time. He sent me a bunch of things. There's more things he included. Right, well, this just doesn't make sense to me because this should not be set up the way it's set up. I'm just trying to find something here. Go back to here. I mean, this says battery assembly. It doesn't say what voltage the original battery was, but the diagram says 6 volts. So it's not like the battery voltage is different. It could be, but yeah, George is coming to see me. The last remaining cat. Right, well, what's going on with this bloody thing? This just does not make sense to me. I'm obviously missing something here. So I think I need to measure the normal supply voltage here when it's in normal operate mode. Oh, that's doing stuff. Right. So when it's in operate mode, it'll be running from this supply, that green wire there. That's the one I need to find, is this wire. So 21029, I know where they come from. Where's that green wire? I need to find that. Or this one. One of those two things I need to find. Or maybe I can measure on Q218. Where's Q218? That looks like it's on the back panel based on those indicators there. Be one of the big pass regulators. Yeah, I think I need to find the voltage here on Q218. See what's going into that. On that collector there. And see what's going on there. So the positive side is rectified, the negative side is not of this one. So that's negative side there. On this one, negative side is rectified, positive side is not. Could that be an influence? Of course, you're tying the positive side of this coil to the positive side of that one. It should be equivalent. Yeah, I was thinking if that went to the negative side of that one, but it doesn't, does it? It goes to the positive side of that one, so it should be equivalent. Shouldn't matter. Just in case it effectively ended up being in series, but front plate, page 20. Page 20. Must be a different manual again. Q218. Here it is there. That's on the rear panel. Yeah. Left one on the rear panel. So I can't even get to those bloody connections because it's away. Cat's not. You can hear that, can you? No, she's got a little step. She's got a step to get out the cat flap because she can't get out. She's too old. She can't get up. Can't climb up into it. So she's got a step to help get her up there. Okay. Well, that's not really helping. So let's go back to this page and let's think about how we're going to manage this. So if I can find that connection that goes to that transistor or that switch point, so that bloody that's a pain in the ass, isn't it? If I just find that transformer connection there, the green wire, if I can find that, might be good. Let's try it. And we're looking for orange. Is that yellow? Yellow and green. So here we've got yellows, potentially, or could it be orange? There's a green there. Then there's like extra orange there. I don't think it's that side, it could be the other side, which I can't even see. I'm sure it's not this transformer. That's something else, I think. That's the mains one coming in, and this is the one which is used for the chopper and stuff to drive that. I think converts the DC to AC for the switch mode section of it. I think that's what it's doing. Anyway, circuit board. Let's look at the circuit board. Can I see wires going to the circuit board which are green? I think I need a torch. I still don't have enough lights. You would say. There's lots of wires there now. There's a green one coming out the back, but I can't really see where they go to. There is a green one there. That could just be coincidence. Where does it go to? Can't see which way it goes. Can't see where it comes from. It's all a bit awkward, really. Comes over here. That's the green wire I can see is there. This shouldn't be this bloody hard. All I'll do is put a battery in it. It's ridiculous. Shouldn't be taking me this long to sort a bloody battery out. Right, let me look at the switch again. Now I've got those diodes there go to that point, right? It gives me an idea of what's going on there. It gives you one wafer to figure out. I might return back to the switch and look at this again. So two diodes come across from that wafer over there on independent switch contacts. Now are they just using that? They are. I think they're just using that as a way of joining wires together from that switch wafer up there. So there's got a black and white, looks like. Maybe a brown and white. Go to that end of the diodes and then it comes over to this switch wafer over here, which also doesn't connect to anything. At least on that side. What is that doing? Oh no, it's got a junction going across. I can see a little wire jumping across, which comes over here somewhere. And then kind of disappears. I think it goes to the end of the resistor here. I think it does. It goes to the end of that resistor. So those diode junctions come across, go to the net resistor, come back. What's going on with that? Let me quickly look at this so I can see what it is. That's the 56 ohm, isn't it? That is the 56 ohm resistor. It must be. Let's find out. Power is off. 56 ohms. Yes, it is. Okay. So the other resistor goes to two tabs on the other switch contact, which will be connected up in the AC and off positions to the wiper of that contact, which will then jump across the other tabs on the other end, and you're blind again. Well, it should be easy to work on, yeah, but it's just weird that it's got that bloody voltage there. So that bridges across two tabs over here, which it does. And it goes to the wiper, which might be on the rear. So, what I say it was AC and off. That's AC, that's off, they're joined together. AC is joined to this one. Off is joins all three together, which joins it across all of these. That's the meter one. I'm sure that's the meter side. Look at the diagram again. Two of those should be on battery test, and battery will be the ones that connect up to the other wiper. That's what I'm trying to find. So battery test and white battery, that's those two positions there. But in those two positions they don't cut to anything. They don't connect on this side. It just goes to a dead end. That can't be right. I'm obviously missing something here. Let's look down the back of that wafer again. I'm sure there's nothing there though. Oh, there's nothing there. There are no tabs on the back of that wafer switch, so it's all on the front of that switch. Or the back of that switch, I should say. That just makes no bloody sense to me. Because that doesn't work. Oh, this is ridiculous. Hour and a half, and we've made no progress. Well, I haven't been an hour, it's probably been about an hour. But yeah, this is frustrating. I blame the beer. I mean the coffee. It must be the coffee. The big cans, one of them is a chopper, smaller one, The larger one is a transformer. Connected to fuse F201, yes. Yes, that's why that other one goes to yes. That's that brown and white, which I saw at the front. Is that right? Yes, that's a brown and white I saw at the front. Because that also goes to that little holder where the battery is. Yeah, special coffee. This is fucking ridiculous. Oh god. Yeah, I mean this game is just weird. I don't know. I'm obviously missing something fundamental here. Maybe the ability to think straight, that could be it. So if I assume that these orange wires are actually meant to be yellow, right, because you've got orange and green over here, right, so it's likely to be a set. I'm not seeing those colours coming out the top of the other side, so I think that green one there is probably the one I actually want. And it comes down here, down to the ball down there. Power is still off, isn't it? Yes, plugging things in here. Making sure. That comes up there, and that goes to the board, I think. It's like a big mess of wires down here. That does go to the board. Right. It looks like the third one down from that group. Third one down from that group. Right. Let's try measuring there. Third one down from that group is there. So I think that's the green wire. Hello, George. Right, what am I looking for now? I've lost the plot now. What the hell am I supposed to be doing? Got to measure the green wire between the green wire and the junction of those diodes to see what voltage we're getting. Right, okay. So that's between there and where's the diodes gone? Lost them. Down there, right. There. Here and here. Okay, got that? Not sure I do. So I'm just going to measure on the transformer output, hopefully, from here to here. Oh, turn the power on, I won't do much at all. Let's turn this on, I think. I'll turn it on just to be sure. There and here, what do we get? Quite a bit of ripple, but we are expecting that because it's basically not filtered there. 14 volts DC. That's what it runs at, 14 volts. Interesting. If I turn the power off, (16 volts with no load). What does that tell us? Not much. Tells us I'm an idiot. I don't know what I'm doing. So between here and here we're getting that 14 or 16 volts. So that's what's coming down here to this transistor collector. So that battery pack could be 16 volts, not 6 volts. I don't know. I mean, it could still be running off 6 volts. It may still work on 6 volts. What voltage we've got down here on the diagram? Does it say much? Minus 13.5. Yeah. I don't think 6 volts will generate that, will it? That buzzing noise is the chopper. It's got a mechanical chopper in it. No, not found it yet. I don't know if it's a fault, whether it's more of a discrepancy. Because it just doesn't really match up. The voltage on this side is 14 to 16 volts between those 2 points. So this battery here, when that's being used, that should be replacing this voltage here. So that's 14 to 16 volts, and that's only 6 volts, and we've got things like negative 13 mentioned here. I don't see how we're going to get that from 6. I don't think it's a 6-volt battery. That's the thing. I don't think that's actually supposed to be 6 volts, even though it says 6 volts on the diagram. I mean, that's definitely a 6, isn't it? That is definitely a 6. Yeah, I did. That doesn't make sense. That's just weird. Run a 6 volts, see if it will run off it? Well, yes, that's a possibility. But then I don't need backfeeding. Oh, if I don't have the power, it'd be alright, wouldn't it? It won't matter. Leave the power turned off, hook up to it, and see what we get. We could do that. Hey Josh, what's R220? Where are you seeing R220? There's 228. I don't know if that's the one you're seeing. Now I'm looking for 220 in case I'm missing something. 220's down here is 15k, so that's obviously not what you're saying. 228, yeah. So that's obviously a current limiting resistor for charging the battery, so it doesn't dump too much current in. Page 3, it does say it on there, does it? Does it really? Fuck. On page 3, it might not be the same one as yours, as you've got. Well, that's page I. Is that matter? Is this page 3? Now I'm looking randomly for it. Because I'm sure I've read it somewhere too. I've read through this a while ago when we first worked on it. I don't see it. I don't see it. PDF page 7. If it's the same PDF as I'm using. Oh yeah, there it is. Yeah, 6 volt 4 amp. So it's definitely a 6 volt battery. So why the hell are they running on 37 volts? That's just weird. Yeah, it says here battery operation. Yeah, and it's 4 amp hour. So yeah. Well, this PDF here is one which I made because I've got the physical manual and it's slightly different to one which is available online. So I scanned it in and made my version available as well because this is a slightly later version, I think. And so this is available now. I think XDevs has got it on there. I think it's already on XDevs and I put it somewhere else too. So it's available online to other people as well now. Yeah. It just doesn't make sense. Why 37 or 34 volts when it's loaded down onto 6 volt supply? Tiny screen. A bit trouble. Yeah. Jacob, how's it going? Yeah. Okay. Well. So 6 volts appears to be correct. It's mentioned in the manual. Shows 6 volts on the diagram. But the voltage is way too high. I don't relying purely on voltage drop across that resistor. Act like a big shunt to drop it right down, and using the battery to manage itself, which is kind of risky. Yeah, voltage injection time indeed. Let's shove 6 volts into it and see what happens. That's easily done. Let's do it. So looking a bit deeper into the service manual for this, it actually specifically mentions a 6 volt 4 amp hour battery. So now I know exactly what's actually in there. So it's supposed to be a 4 amp hour battery. Now the one I want to put in is only 2 amp hours. But I don't care. It's not going to be used for long periods of time. It's going to be used occasionally, once in a while. So that's fine. But the weird thing is, it does say it is definitely a 6 volt battery. And we're still getting this high voltage across here. So I'm just going to shove a voltage into it first and just shove 6 volts in at those battery terminals from my power supply. And we'll just see if it runs. Because that will prove once and for all the battery is definitely correct voltage. And then we have to figure out why that voltage is like up to 37 volts when it's been smoothed out by the capacitor. Because that does seem excessive for a 6 volt battery. You know, obviously you've got a charging circuit, so you do need to have a voltage higher than that to be able to charge a battery, but having it 5 times higher, a bit much. Let's have it going again, it's gone to sleep. Get on, there we go. And over there, we've got 6.5 volts on that side, that's close enough. AC only 7 hours. Yeah, overcharging, yes. I did see some comments about not overcharging it. Or over discharging even, that's mentioned too. So it could be that it is relying on that resistor just to drop the current down and drop the voltage. It could be why. I mean, it is a massive resistor. It's probably, was it, 5 watt resistor or something like that? Is it maybe 10 watt? Not sure. Be in the parts list. Someone look out for me. R228 in the parts list and just find out what value that is. What its wattage is rated as being. And YouTube app quit again. What's going on with this thing today? Garbage. It should provide 6 volts when I turn the power on. Make sure that's in the off position. Battery position, once I turn it on. Right. I'm pretty sure I didn't got it backwards. So let's just try powering this up now. AC power is turned off, so it's not trying to charge, because that could be disastrous, trying to shove voltage back into a power supply. Some power supplies can tolerate it, and most of them can't, and you end up blowing up your power supply. You need a proper 4-quadrant source meter for that, really. Anyway, turn the power on. That's running at 6.5 volts. No current's currently being drawn. Change the battery position. Okay, it started up. It's drawing 200 milliamps, and it's capturing the power supply. I've got the current limit set too low. Set at 500 milliamps. It's still dropping. Let's go slightly more. 700 milliamps. Set it to that. Okay, so that is running off 6.5 volts, and now it's settled down. It's doing just under 400 milliamps. So it looks like it will actually run from that voltage. Now let's inject the voltage into it and see if that works too. This is a long way to wind this thing in. It's almost there. Here we go. I might just shove these in. So let's do 1 volt on there. Let's just shove these in the terminals here. That should be good enough for now. Just testing. Shove those in there. Let's do 100 millivolts. Yes, that is working. 2 millivolts. Yep, that's definitely reacting to that. 1 volt should be full scale, and it basically is there. So yes, this is actually operating off 6 volts just fine. So a 6 volt battery will run it. Okay. Shall we see what voltage it will drop down to before it decides to not behave properly? Let's do that. Actually, do it like that. So 6 volts. My terminals will just come off. Put them back on. Try and hold these terminals on. The chopper's changing. You can hear the chopper changing. That's 5 volts. Four volts. 3 volts is, there you go, that's killed it there. Bring it back up again. So it looks like you could say probably safe margins 4 volts. Absolute minimum. Maybe if I get good connection again. So 4 volts, absolute minimum. But it sounds happier above 6. The chopper frequency doesn't change between 6 and 7. .7 the chopper frequency changes. So it needs to stay above 5.7. Okay. You have a little bit of information at least. Still doesn't really explain the bloody voltage difference though. That's ridiculous. Well, it's a 10 watt resistor, is it? Great, thanks for that. Yeah, I thought it might be 10 watt, 5-10 watt. Most test equipment, no, Siglent Park's got way more than me. And he's got much nicer equipment than I have. And worth a hell of a lot of money, I expect. Think how much his stuff costs. All up. It must Yeah, you must be doing pretty well for yourself. Actually, that's what I could look at, is what the battery test mode says, couldn't I? I could look at that. Because we've got the battery test mode here. So we can actually look at that and see what it shows up as. Okay. Drop this down a bit and see if it. Is that kind of focused? Right, so battery test mode. 6 volts going in. Let's count to 6. Almost 6. So 7 volts. Yep, okay. So maybe that's 8 volts. So what would the maximum voltage be on one of those? Was it charge voltage on each 1.2 volt, and like had to be 1.5, is it? So it could be 5 times 1.5, so it'd be 7.5. Got that right? Maybe? I don't know. Anyway, 8 volts is doing what's 8 volts. So that top scale was basically giving us the voltage reading. Interesting. Well, I was fairly comfortable going above voltage then, because the short these together. There we go. Yeah, it's quite comfortable going above that 6 volt level, because obviously it's got to have a charge voltage going in, which will drag those batteries up. So obviously a 5 NiCad pack will be 6 volts. So 5 times 1.5, 6, 7.5, yeah, 7.5 volts would be the maximum charge voltage, I think. Fortunately there's no markings on here to say battery, but you know, it would have been simpler. Yeah, we've got the rise in it. Maximum charge voltage for a NiCad 1.5. It's not doing any kind of complex detection, it just drops through a resistor. It's extremely basic. Let's go back to the diagram I showed. I don't know if you noticed that or not. So, this diagram here, once you see, you probably understand what I mean. Got a bit bigger for those on smaller screens. So the supply comes in through here. It's got its dropper resistor, which then is what charges the negative side of that battery. Right? It's got common positive, and the negative is the one that's fused, and it's got the charge dropper here through that resistor. So it looks like it's purely relying on that resistor to stop that battery being overcharged and being excessively loaded. So that's quite surprising. I mean, if you've got a piece of this gear sitting there on power for, you know, a day, it could be doing bad things to that battery. Well, if I'm on this camera, really? You reckon that's better audio? Well, over here will be. Over here I'm using a different mic. Got 2 microphones. Got this ceremonic which sits in the corner of the desk there, which I thought I'd disabled and everything. Obviously I missed one. You reckon that one's better? I actually prefer this one. Okay. Interesting. Okay. Right. So if you've got a 10 watt resistor there, then it means that we're expecting to drop an awful lot of power through that resistor. Why on earth did they use such a high voltage there? Yeah, I actually prefer this microphone. The other one's meant for when I'm over the other side of the desk, but I thought I disabled that completely. I thought I'd turned it all off and everything. Desk is noisy. The other one, yeah, well, it's got a lot going on. It's got the power supplies by it and everything, which is why I disabled it. So this one here is using the other microphone. If I now change it to ground, oh, where's the microphone? Hold on. I need to do something here. My microphone's not even in the list for some reason. Turn that microphone on. Turn that microphone off. There we go. I think that should be there. Right. Yeah, the desk, the microphone on the desk has got. It's right next to a power supply, which I've started using recently because it's running all my lighting. So it does have a fan running because of that, which is why I thought I disabled it, but I forgot to do one apparently. Looks like it's the only one I missed. Just that one. Yeah, cool. Alright. Yes. Yeah, I missed that one. I forgot to change that one over. Okay. You said told me earlier I could have changed it ages ago. So I'm not happy with that voltage going in there. But why on earth did they design it such a high voltage to charge a 6-volt battery? That just makes no sense. Now the thing is, it says 6-volt there. I also have some 9-volt batteries. Now, as this other supply, which it also runs, can be 9 volts because it's running that 14 volts or so from that supply rail. Let's go back here so you can see what I'm pointing to. So that's that 14 volt rail is here. And this battery is supposed to replace that. So I could potentially put a 9-volt battery here and help reduce that difference in voltage. It'll still be within a scale of a meter because it goes up to 10. 11 would be better, but 10. I don't know, do I do a 9-volt battery and not fully charge it and just have it sitting so it'll never overcharge? Set it so like I charge a voltage of 9.5 volts or something. Put a regulator at 9.5 volts. Interesting. Or maybe that battery pack they have for this, maybe that's got some circuitry built into it which handles it as well. Maybe that's possible. Although it says a simple battery here, maybe the battery pack has circuitry in it. Maybe it's got built-in regulation in the battery pack. That could be possible. Don't know why you do it that way though. It'd be, you know, you'd be able to put charge circuitry in here. But anyway, you know, right there at that point. Ah, that's why I was asking about the fan, right? Okay. The line on the right, that just goes through to the meter, so it goes across the other diagram, and it's just for when I did that test just now and showed the battery level. That's what it's measuring. It connects to that line there to the meter, so you can see what the battery voltage is. That's all that does. So, yeah. I really think I need to do something. At least I know where this resistor is. So I could do something right where this resistor is, interrupt that line, and put a regulator there, and drop that voltage down with a regulator so it's under control. So then it could be left on charge safely. That could also be a good benefit. The old battery's gone. It wasn't here when I got it. It's already been removed by someone long ago, I expect. So there's nothing for me to refer to as far as what could have been there. You reckon there's something suspicious about the resistor, do you? Well, I mean, I just see that as being a big current dropping resistor to drop that 37 volts down to 6. Or, you know, 8 or whatever it might need for charging. So, and that's why it's also so big, because it's got to drop so much power across it. So I'd probably keep that resistor in place and put a regulator after it to take stress off the regulator. But then that's like 37 volts, which is too much for a 7909. because they're going to go to like 32 max. So even that's very complicated. Yeah, that's right. That was just there. So, yeah, this simple battery installation has turned into a bit of a nightmare, really. I mean, yes, I could drop it in there, and it might be alright for half an hour before it explodes. I mean, I don't really want to design a regulator circuit just to bloody do it. You know, using pass transistors and stuff like that. I mean, it's doable, but excessive. Hey Chris, use a zener. Well, strap a zener across it to help stabilise it to get it down. That had to be a pretty big zener because that looks like that's a 10 watt resistor. So they're also expecting a lot of power across there. So yes, it did cost a mind, but I was thinking about power usage and how much power that zener's got to be dissipate in order to get that down to 6 or 8 volts or whatever. I mean, that would be a nice, simple way of doing it. Stick a zener across it to after that resistor, so the resistor's dropping the voltage down nicely. A few diode drops. Well, it's only, you're talking about 0.6 volts per diode. Although when you've got heavy current going through them, it could go up to like a volt with heavy currents going through them. So you need a few of them, but I don't like to go too close to the limits of regulators because you don't want to blow up and then pass full current through. Yeah, I'm just not liking that setup at all. Yeah, the only problem with this is that it's a negative supply, not a positive supply. So, if I modify that side, it's a negative supply, right? If I interrupted this side, that'd be a positive supply. Should I interrupt both sides? If I interrupted both sides, that would give you a lower loading on each regulator. It'd be halving it across each one, right? So if I put in, say, we'll have to get, I wouldn't be able to use a 9, but I have to use something else. Wouldn't I have to use a 5-up rig? 7 out of 5 each side. That'd get down to 10 volts. That could work. But dropping, what we got there, 18 volts each side, roughly, through a regulator, linear regulator, that's going to get bloody hot. Replace the battery with a zener. We just want to see what it drops down to. We could do that. Drop a 6-volt zener in there and see what happens. And to see what happens to see if the zener goes bang. See how hot it gets. We could do that. This is an experiment. I mean, we've got a 56 ohm resistor here. We could measure the voltage drop across that resistor and tell us how much current's going through the circuit. We could do that also. Yeah, I think Josh, what Chris is mentioning is to test the loading on that circuit to see what happens with the zener in there, to see if it can actually handle having a zener across that resistor without the whole thing catching fire, basically. It might work. That 10 watt resistor might just be overkill, but it might handle it. The biggest zeners I've got, I think it's only 1 watt, the biggest zeners I've got. Let's have a look. 6.2 volt zener. So 1 in 4735, I think it is. So what I could do is hold the zener across the terminals, and if my fingers start melting, we know it's not working too well. Right, let's kill that power supply. Get these terminals off here. I can actually use the same connections. And what I might do actually is clip across a meter and see what current we're getting. We could do that with a 6.2 volt zener in there. So that would kind of simulate a battery. I do have electronic load here as well, a DC electronic load. I could try hooking that in, but I'm not quite sure how it's going to handle the AC ripple. I don't know if it's going to like it or not. Might be fine with it. Let's take these out and let's see. Guess I'm going to hook it up backwards, isn't it? Okay, get that out of the way. New clip lead. Another clip lead, I should say. Yeah, I'll be able to do that. It's okay. That'll work. In there. We shall stick the zener across this and probably get right around. We can try. Piggyback those, and you can't see what I'm doing because I've got to switch everything over. Alright, so I've got a zener clipped in here, running through the Fluke multimeter. These piggyback together, which I'll put in and drop on the floor so I don't get them out of the way so I'm short on against anything. Positive side's coming to the negative side of this, but yeah, you get the idea. So that's the. Hold on, let's make sure I've got this right. Ouch, just on my finger. Negative comes in, that's going to be negative. That's wrong, it should be negative. I've got this wrong. So I'll have to double check these things. I thought that was wrong. That'll be negative coming through here. So that'll be negative side out of zener. Positive side is that, isn't it? And set the positives together. These then tell us how much current's being drawn as well, and we'll see if the thing catches fire. Right? What could possibly go wrong? Get this out of the way so that short something, like I said. Okay. I'll turn it off for now, not to confuse things. That's off position. Actually, I'll put it at the battery position because that way there's no power coming trying to charge it. When I go off, it will try and charge. So I'll start there. Well, I'm going to try an experiment. I've got a 6.2 volt zener here, which I'm going to use to effectively simulate the battery loading. This probably will go bang. I don't know if it's going to last because we're dropping 37 volts down to 6.2 volts through a big resistor. Now it's a 10 watt resistor that drops down through, so it's expecting a lot of power. This is a 1 watt zener. 10 to 1 difference. We'll see what happens. But I've got the meter here set up. Not better put the DC, otherwise it won't make much sense. So DC amps, we should be able to see how much current's also trying to go through the zener to drag it down to 6.2 volts. And it might give us some more information about what's going on and how safe the circuit actually is to put a battery into and what I may need to do to make a circuit work. So I think I'm just about ready to try this. I've got it set to battery position, so it won't actually be trying to power it straight away because battery position doesn't try and power it. This will be, it is connected, but it's not actually trying to run AC through it. So I should be able to turn the AC on, be safe there. As soon as I turn it to the off position, that will then be trying to apply power to this zener. We should see a current and hopefully it's not more than 10 amps. If my fingers start melting and smoking, let me know. $260 milliamps. That's not that bad actually. I was expecting more than that. Question is, how hot is the zener getting? Because don't forget, it is dropping a lot of voltage through that resistor as well. That's getting pretty hot. I can't keep my finger on that, definitely not. But that's only 260 milliamps, so that's the maximum charge current it could potentially put into the battery at 6 volts. That's maximum charge current. That's what that's telling us. Okay. So now the current. We know that resistor there is a 10 watt resistor, 56 ohm. We've got some numbers there we can actually use to do some maths and figure out the voltage drop across that resistor and things like that, and how much power has been dissipated in that resistor. But this zener is very hot. I could get the thermal camera out. Let's do that. I'll leave it on so it keeps on warming up. Keep it realistic. Check the chat. Yeah, there's no capacitor right now. That's right. Yeah, R228 is a transformer, yeah. But having a 6.2 volt zener across there is going to be like having a battery pack. It's going to be the same equivalent thing. Maybe drag down slightly harder than the battery will be, but not by much. .6 watts through the zener, so yeah, that's why it's getting a bit hot. Thanks for working it out for me. Let's try and get this so I can see it on camera, shall we? Oh, it's got a thermal camera out. Let's have a look. This is what we're getting here. So that zener is 144 degrees or so, 145. The clip leads are about 44. So yeah, that zener's absolutely cooking. That is 151. Yeah, 151 degrees. It's still going up. So let's turn it back off again and give it a break. There you go. 100. It's down to 98 now. 80. It's dropping down quite quickly. But yes, that's yeah, interesting experiment. But at least we know what the maximum charge current is now, which is helpful. Yes, well, is this device for sale? What device? My little... the thing I'm working on right now? Or are you talking about something else? Or the thermal camera? This is something I'm going to keep. I'm planning on keeping this device. Because it's one of the few things which can actually measure very low levels I've got. You can actually get some old stuff quite cheaply on eBay. Depends on what it is. Some things are ridiculous money. A good thing to look for is like a differential voltmeter. I mean, they're relatively cheap if you want something just, you know, old and has still some use in it. Fluke 845AB looks one of those. Saw one of those on there the other day, quite cheap. It's still got a use. A lot of the gear I buy is either just to fix it. I do get things which I purely to repair them. A good example of that is this thing over here, the WaveTech 178. I've got no use for that whatsoever. I don't want it really. I just no use for it. It's still a useful piece of gear if it works. Once I fix it, it'll be useful to someone, but it's of no use to me. So that's something which I will be selling when I fixed it and give it an overhaul and give it a new lease of life. But things like this, which are quite specialised, which fill a gap in my equipment list, I suppose you could say. If I don't have anything else that can do that function, then I'll keep it. Like in this case, this can measure really low voltages, really low currents. So I'll be keeping this. You got the same Unity? Yeah, it's a nice little camera. It works quite well. Very happy with mine. Yeah, anyway, so we got that sorted out. So we know the charge current is 1/4 amp. Okay, well, catch you later. So charge current is 1/4 amp. So you think about that power that's going into that battery, right? So it's shoving 1/4 amp constantly into that battery. So that zener is a 1 watt zener, and that's struggling with it. So that's a lot of stress on the battery, even normally, isn't it? That's an awful lot of pressure on. Yeah, that's a lot of pressure on it. I mean, if it wasn't trying to push so much current into it, it'd be doing better. I should have checked that resistor actually, shouldn't I? See how that resistor was getting. Although you think if the 1 watt zener is getting up to 150 degrees, and it's 1/10 of what the resistor can do, and the resistor's got a larger area, it should barely be getting warm. Right, for 4 amp battery, yeah, potentially. But I still think that it's too much voltage for it. What if I put a charge controller on the positive side of the battery connection? It mentions NiCad in the service manual there, Chris, so it was a NiCad battery originally. Well, unfortunately, I don't have the old battery. It was, I don't know where it is. I've never got it. It wasn't in the unit when I got it. So someone at some point has taken their battery out, probably because it was failing. Don't forget, this thing is pretty old. So yeah, so I'm thinking if I put some kind of battery management on a positive side of that battery, that could work. 6 volts though. I'm thinking about how I can do this. Because it also has to work when it's in use, so it can't be one directional. So it's not just only putting power into the battery, it also has to come back out. So because it's going to be running from the battery. So I can't just put something on the positive side unless I interrupt these winding from the transformer and put it in that section. So it's purely the charging circuit that's affecting, not the whole thing. Which is why I need to put it potentially on the negative side by R228. Yeah, I think I'd rather have a better voltage control rather than relying on a resistor. Because if it does get plugged in and left for days or weeks on end, which could happen, what's going to happen to that battery? Is it going to explode? You know, it's one thing saying, oh, don't leave it plugged in for more than 7 hours. Well, reality is, someone's going to leave it plugged in for more than 7 hours. So, yeah, that should have been a much lower voltage coming out of there. That's just ridiculous. Yeah. I have to think about this. I don't think I'll be able to finish it off tonight because I've got to think about how I'm going to modify this to make this work nicely and be robust enough. I mean, maybe changing it to a current source, putting a current source in there, so I can limit the charge current to like 100 milliamps or something like that. That might be an option. I've got loads of BMS modules, but they're all for lithium. And that shouldn't matter too much if I say get I think it's like 8.4 volts for 2 cell, which is getting towards the top end of what it should be doing. Should be less than that really. But I'm not quite sure what the maximum voltage was on those. Current limited back regulator, yeah. Yeah, I need to do something like that. I may keep the resistor there though, just to add an extra level of protection and just to take stress off the buck converter. So it's got a little bit of a cushion there, so it'll go through the resistor, then to whatever charge management system I end up using. Buck regulator, some kind of charge circuit, charge management thing, I'm not sure yet. Current, maybe I don't know, current limiting circuit, like a constant current source kind of thing. So it drops it down to a fixed current, and that's what it will use. And then you could then use that to run through a regulator to take the stress off the regulator. Because you're only shoving, say, 100 milliamps through a 708 or 708, whatever it might be. That could, or 7908, it would have to be 79. That could work. Because you're limiting to 100 milliamps, that's not going to get that badly hot. Using some kind of regulator system to drop the voltage down, a current limiting system and a regulator, or some kind of BMS system which will drop it down and handle that up to 40 volts level, which is there. Well, up to negative 40 volts level. What's the problem? It's a negative supply. So that makes it more complicated because normally you just do a positive regulator, positive BMS. Although they do tend to be in the negative side when actually active, don't they? A lot of BMS is actually active in the negative side of the battery. May not matter. Several things to consider there. Yeah, current limited regulator would work, yeah, that's what I'm thinking. Because that way you're not dissipating all the heat in the regulator. That's what I'm leaning towards. Because when you drop the current, it doesn't need to be a high charge current, doesn't matter. I mean, when it's running, it's only doing, what, 300 milliamps? So, in theory, let's say 400, round up 400, right? So, to maintain, let's say 50% battery usage, say we've got 1 amp hour to use, so I can run it for a couple of hours quite safely, 2.5 hours to get down 50% capacity of the battery, which is where when the voltage is probably going to start dipping off a little bit. And I don't like to discharge batteries too much, so that could be, even 2.5 hours of usage is probably going to be enough. So I'm not worried about fully discharging the battery, so charging it up by that much takes 10 hours with a 100 milliamp limit. So what? So the problem is, Q's, anything I sell would have to be sent to you overseas, and that causes a large increase in cost. It'd be far cheaper for you to buy things from eBay. Choose carefully. Well, that's what I recommend. And then you also get some projects to do videos about. That's what I'd recommend to you. Yeah. The thing is, resistance isn't going to stop the voltage increase. It will just keep on going up. Alright? So, as the current drops, the voltage will increase. So, resistor is not ideal. It needs a proper limited regulated supply of some kind on that negative side. Why they didn't do that when they designed it, I don't understand. It's just, they did all this other stuff really well. Battery charge circuit, non-existent. But like I said, it could be in the battery itself. That's why it's not actually within the unit. It could be what they did is they put it within the battery. Because they may well use this battery in other devices as well. I don't know what they used them in, but yeah. Yeah. Okay, I think that's all right. I'm going to have to. I think I'm going to think about this because I have designed a current board, like a current limited board, like a current sink, current source. Depends how you want to interpret it, really. You put a voltage into it, and it outputs 100 milliamps. So I have that module which I've built, well, which I've designed. I've got circuit boards for those, so I could easily build a 100 milliamp current system, so it produces 100 milliamps current. Doesn't keep out voltage, doesn't matter. It just produces 100 milliamps current, and it's using a transistor, I think, which is rated for 80 volts, something like that. So that shouldn't be a problem. So I could probably integrate that into it to limit the current to 100 milliamps, and then use. I'm still worried about the voltage going through, though. It might be right. Maybe I should use a larger value zener after the resistor. Say put in something like a 30 volt zener. So it's dropping a little bit across that resistor straight away through the zener. So it clips it so it doesn't get excessive. And then I could use a 7908 regulator after that point. So I could use zener across the resistor to drop it down to about 30 volts. That's safe for the regulator. And I could put the regulator after the current limiter. Or it could be either way around, actually. Probably could be either way. Not sure which way around I should do that. Whether I should put before the regulator or after the regulator on its lower side. Not sure. I have to think about that. Because if I'm putting it on the higher side, that's higher wattage, isn't it? So I put it on the lower side of the regulator, that's going to be lower wattage. So that's going to be what, 0.9, 0.8 watts effectively. If I put it on the low side, put it on the high side, it's going to be potentially 3 watts. I think I got it right. Yeah, that's what I think I should do. I'm going to build something for this. I think I need to build something for this. So yeah, regulator across it, zener across it, current limiting circuit, regulator IC to the battery. That'll probably do it. I reckon that'll be alright. I'll be much happier with that because then we're not overloading the regulator with the input voltage coming in. You know, I'll choose some level which is safe for the regulator. I mean, even 30 volts is a bit on the higher side. Probably, maybe 24 would be safer. I've got 24 volt zeners. How much power would that be regulated? Zener dropping in that zener then. Maybe you could try it. Put a 24 volt zener on, see how much current it's actually dissipating, and see how hot that gets on a 24 volt zener. Although it would be shared with the regulator, so it won't be completely on a zener because the regulator will be pulling it down as well. That will help. I'm not worried about drop of resistor at all. I'm not worried about power dissipation in that. What I'm worried about is overloading the regulator, overloading the battery, and overloading the zener. So having a combination of a current controlled charge system by using a current regulator, that will limit the current, which will limit the power dissipation, which takes a lot of stress of everything. Putting a zener before the regulator means it won't overload the zener, overload the regulator with too much voltage. So we're controlling the voltage into the regulator, we're current limiting the charge power, which takes stress off the regulator, stops the regulator getting too hot, so it will last longer and won't be so worried about trying to get heat dissipation out of the unit. And I'm not worried about charge time of the battery. I'm not worried about that. If it stays on, it takes 10 hours to charge it up from half full, so what? And if I do it this way, if I can control the output voltage nicely, leaving it on charge for a long period of time shouldn't be too harmful. I mean, an 8-volt regulator is probably a bit much for that. Probably want something closer to 7 for long-term charging. Could I pull it upwards? Don't think I can pull it upwards unless I have a feedback circuit of some kind. Because if I stick a diode in the ground leg of the regulator, that will give you a shift of a diode drop, but it will increase the difference, not reduce it. So that wouldn't work for that case. The subscribe count, I built that, yeah. I don't know. It's max displays. I can't remember what the numbers are now. 8x8 LED matrix displays with max processors on them. They're in series, and it's using Brian Locke's YouTube API, and it's grabbing the details using that. You have to get a API account with YouTube so you can grab your details. That's all programmed into the actual code. Could I build one? Nah. Sorry, mate. I don't have the bits. I don't have all the bits to do it, and my code is probably not even going to work now, to be honest, because I built that years ago, and I've updated my system so much recently. I'm actually having trouble trying to get some of my projects to work, so probably not. I mean, Q's, you're probably capable of doing it. I mean, you do a lot of electronics work yourself. I imagine you're capable of building it. Maybe it's the coding side you're worried about and the actual programming. That could be the tricky bit. I guess you're worrying about that part. Yeah, anyway. Okay. So this stream today has not gone at all as planned. So the spooling stream was a disaster with the power cut. This stream has been interesting and surprising. But at least I've got a direction now. I figured out what I should do to control this system. But I'm thinking if I need to allow for long-term charging, so it's on charge for a week without destroying the battery, I need to think about that part, which makes you think about battery management IC. Can I get a BMS for a nickel metal hydride battery pack? Because if I can get a BMS which can control the charge rate of that battery, that might be the way to go. The coding you can't do, are you? Yes. Yes, things have been interesting today. I need to research to see if I can find a BMS that can do a nickel metal hydride 6-volt battery pack. Because if I can get an off-the-shelf BMS, that might be better to do than building something. Because they might find a BMS which can accept that big voltage range. Because what they do generally is they've got MOSFETs on them, and they'll just float the rail up, right? So you got the main power comes in, and the battery's on its its own section. So it's main 12-volt line here, negative rail here. But the negative rail, usually negative rail, has got a MOSFET in there. And what it does, it monitors the voltage on the battery side, and it adjust the voltage on the MOSFET to control the MOSFET on state to float the battery up. So as this voltage of the battery gets higher, it turns the MOSFET off more and actually float the battery voltage up. So if you compare the battery voltage negative and the rail negative, you'll see the battery MOS voltage gradually comes up as they're charging. Yeah, that's right, Josh. I had a problem this morning. I actually popped into Clive's stream a bit later on. Whilst it's still streaming, I mentioned it in there. Because some of the people which were watching the stream then were on Clive's already, because they switched over to Clive's stream because mine had died. So, yeah, it was a bit of a disaster today for that. Yeah, but anyway, that's what the BMS side it looks like. So, a BMS is safe to use on it because it will just float the battery voltage up. So, whilst it's charging, it'll float it up. And if you're running a battery, it won't matter because it should run through the battery. This battery circuit will backfeed because it's designed to run off a battery as well. So the battery will come out, battery voltage will come out fine, unrestricted. The other thing I considered before was running a 9-volt battery, didn't it? That was another thing I thought of. But let's get towards the top end of that meter range. I mean, the meter can go to 10. So if I'm doing a 10-volt charging voltage to get that 9 volts, or I could be, if I use a 7909 9-volt regulator and run 9-volt battery and just never fully charge it, I mean, that would be safe. Then you could leave it on charge forever and it would be fine. Yeah, exactly. Charging circuit's independent, so I could do that. All I have to do is make sure the battery can power the circuit itself, right? So I have to interrupt. I'll go back over here. So I have to interrupt this bit here, right? Any charge circuit modification I do has to be in here to keep it simple. That way, this battery can discharge through the switch and power the unit as per normal. But I think it is safe to put like a 9-volt battery in here. And if I put a 9-volt battery in and the 9-volt regulator, that might be the way to go, because then it could stay on charge the whole time. Wouldn't matter. You know, there's no restriction there. But obviously, you're never going to fully charge a battery. It's always going to be half to 3/4 full, maybe. And that'll be a nice, safe way of doing it. You never overcharge a battery. Another battery will have more capacity, because I think the batteries I've got here are larger. Yeah, they've got large capacity, so maybe. Well, the actual total capacity will be effectively more, because you can discharge by a larger amount. Which I'm not really worried about anyway. Like I said, 2.5 hours of runtime will be fine anyway, even if I've only used half the battery capacity. So that would be alright. That might be the way to go, use a 9-volt regulator, 9-volt battery pack. And also again, the 9 volts to the 6 volts is less stress on the system as well. That's a smaller differential. Yeah, I think 9's safe. Below 6 volts, it started to have issues with the chopper changing frequency. I could hear it slowing down. About 5.8 volts seemed to be like the threshold where it starts to slow down, like it's 5.7. I heard it change. It might be changing at 5.8. So below 6 volts is a bit dodgy. So being on the higher side is probably safer. Yeah, I think that's the way to go, is to go to 9 volts. And that would simplify so many things. I could still current limit. Still do all the plans with a zener across the output from that resistor, regulator, and current limited. But that would mean it could be left on charge indefinitely without blowing the batteries up. I need to go away and build something, I think, to make this work. Because if I do it that way, I don't have to worry about BMS. Because it doesn't matter, because it's going to be fine. It will never be overcharged. Yeah. So we lose a bit of battery capacity because it's not using the full battery pack capacity. But that'll be okay. NiCad's 0.8 per cell when flat. So it's 5 cells, that's 4 volts minimum. Yeah, and that's about where it cut out as well, about 4 volts. And it was still working down to about that level, about 4 volts or so, wasn't it? So, but the chopper was slowing down. And that chopper frequency is actually filtered, so it's got filtering adjustments on the board to filter out that 94 Hz chopper. So, keeping it above that threshold where it starts dropping down, I think is good. That way it keeps that frequency consistent. So therefore that filtering, which is to filter out the chopper noise, will also be consistent. Yeah, I think that's where I need to go. Right. Been an interesting stream. It's been an interesting day. Yeah, that's right, 9 volt pack fixes all that stuff. So it makes it much simpler. Convert the voltage to 9 volts instead of 6 volts. I'm going to shove a 24 volt zener across that thing and see what happens. I'm pretty sure I've got one. I do. .24 volt zener. We'll do the same test again. Wake the camera up. Wait this back up. Okay. Thermal camera, I'm going to need to get that again as well. I keep going to the wrong drawer if I know exactly where it is. Right, AC is on, so let's turn this on. So that's only 100 milliamps with a 24 volt zener across there and dropping down. Let's wait for this to warm up. Come on, here we go. But still getting a lot of heat there. Look, 142 already. So even though the current's much less, we're still getting massive heat here. Maybe this isn't the 1 volt zener, might be a lower voltage one, lower wattage one. Might only be a half watt or something. Not sure what it is. That's 140 degrees. And the resistor in there, which I forgot to look at last time, that is about 38 degrees right now with that zener. Let's see what it does with the other one. Be careful not to grab the other one because it's going to be a bit hot. Do it again. It's 48 degrees, 49, 50, 52. Let's get everything going up. There's also the other diodes. The diodes on the switch are getting hot. They're about 90 degrees now. And that's 88 degrees for the resistor. Yes, those diodes there are not liking that current draw. They're 93, 95 degrees now. So that's not good for it. So yeah, that's definitely, maximum current is not good for it. It does not like that. Let's check the diodes again when I do this. See what it's like with this 24 volt one again. The diodes are cooling down. Fortunately, the resistor is still the hottest thing in the shot, so it's trying to grab the sensor reading, but the diodes appear to be about 30 degrees now, maybe 40. It's a bit hard to see it really. Diodes are about 45 degrees, which isn't too bad. 47. Yeah, so 100 milliamps or so isn't too bad for it. Still a little bit on the high side, but it's handling a lot better. The maximum charge current with 6 volts is excessive. That is not good for it. It's just working too bloody hard. Right. And I should probably record some of that, shouldn't I? And I'm an idiot because I should have been recording some of that. Let's get a slightly better shot. I wanted the thermal camera again. Now I've turned it off again already. Takes a little while to boot up. I'll just describe it. So I'll just try different zener diodes. This one here is the 6.2 volt, which we tried before, which was drawing about a quarter of an amp, which is like its maximum charge current. This is basically simulating what the battery would be doing, alright, from what I can tell. But that's a lot of power dissipation going on in here. Now there's a resistor in here, which is designed to drop the voltage and drop the current to that battery. That's getting quite hot, it's like up to 90 degrees or so. But there's also the diodes which feed it from the transformer. They're getting about the same temperature, get up to almost 100 degrees. And it'll probably keep going up and up and up until it probably fails. But that seems like an excessive current. It doesn't like that. So if I've got a 24 volt zener here, that draws about 100 milliamps instead, which is doing a lot better. The resistor's running colder, it's running about 70 degrees. The diodes are down to just below 50, which is a lot better. Still a bit on the high side, but tolerable. That's okay. It could be nicer. But that says 100 milliamps is like the largest current we want to draw through this thing. Now if I can do less than that, that's even better, and I probably can. So I know that if I stuck a 24 volt zener across the output of that resistor, which is part of my plan, it might be okay, but it's wasting a lot of power into this. Now if I think about that aspect, that's 100 milliamps going through this zener, which is getting really hot. It's about 150 degrees this gets up to, which doesn't leave much power left for the actual regulator and the charge circuitry, which also needs to be added onto that 100 milliamps. So I think this diode, even this, is still a bit too low a voltage. I want to cap that voltage so it's a safe voltage for the voltage regulator I end up using, because I'm going to use something like a 7909, and that can then drop that voltage down from like 30 volts or so down to 9 volts. Now those regulators can't handle too much of a input voltage. I don't like it. So the 37 volts or so that we're getting floating in the circuit here, that would be bad for it. It would likely blow it up. So if I get down to about 30 volts, that'd probably be okay. So I was thinking 24 volts because this is a zener I've got is 24 volts, but that's probably too much still. I think I need to go about 30. That should halve the current roughly, so that should be about 50 milliamps going through the zener. Roughly, I'm just estimating this, but that will leave power left to go through the charge circuitry and charge the battery. If I can get this design right, I can actually do this so that the battery could be left on charge indefinitely without damaging it and without things overheating. Originally, from factory, these could only be charged for about 7 hours before you have to stop charging them, otherwise you'd overcharge the battery. So, according to the manual anyway. So I think if I do this right, I can have this so you can charge it up and just leave it on charge, it'll be fine, it'll be perfectly safe. And obviously the trade-off in that is that it will take much longer to charge up. It might take you a day or two to charge it up. But so what? If it runs for 2 or 3 hours, I don't care, because that's plenty of runtime for me. I might only use this thing for 10 minutes at a time. Once a year or once a 2 years, I don't know. But I don't expect to get much use out of this. you know, I will use it, but it's not going to be something I use a lot. But I need to be ready to go, which is why I want nickel metal hydride. But yeah, I need to make sure this system is good. Another alternative is to completely change it and just not charge off the internal power supply at all. And that is to run my own power supply to it to charge the batteries up. You just plug in a plug pack and charge up the battery, and that'll do it, and that's it. And ignore the original charge circuitry. That's an option, but I'd rather keep it as original as possible and just modify that charge circuitry so you don't have to think about it, you don't have to have any special weird things you have to do. You just plug in the power and use it like you would do normally. That's what I'd rather be doing. There's always options, but that's what I'm thinking of right now. So what my current plan is to have a zener across the output for that resistor, which would normally go to the battery, right? So that's going to drop the voltage down slightly, make it safe for the regulator. Then I can have the regulator going to a current limited system, so like a 100 milliamp current limit. So I've got a little board which I designed a while ago, and that's a 100 milliamp current sink or source, so you want to approach it. It goes in series with a supply rail, and it limits it to 100 milliamps. So that I could put in circuit, and that will limit the current to 100 milliamps. If I put that on the low side of the regulator, that'll limit the regulator output to 100 milliamps max, which takes stress off the regulator. It takes stress off the rest of the circuitry, and because you're dropping the voltage down, it may have an impact on that as well. Power dissipation, stuff like that around the circuit. So I think that's an option. I could always change it to a different voltage, a different current. I could make it less than 100 milliamps. I could modify the circuit so it runs at say 50 milliamps instead, and be even better. That's something I'm likely to do. But I think that's what I need to do, is build that charging circuitry and modify this to power a 9-volt battery pack, not a 6-volt. Even though 6 volts is the original pack, if we go down to 9 volts and use a negative 9-volt regulator, that will mean that you can actually have this thing plugged in indefinitely without overcharging the battery, because you've got 9-volt regulator, 9-volt battery pack. You'll never fully charge a battery pack, that's fine, but you never fully charge it to the point where it overcharges. So that's the plan. Bit convoluted, took hours to get here, but we did. Alright. Okay, Goose, catch you later. You've probably gone ages ago. A battery simulator would have been good here. Yes, actually. Daniel, you watching? Daniel? Mr. Bogdanoff, are you watching? Can you use a battery simulator, Daniel? I know they've got one. Hey Peter, how's it going? Yeah, I don't like running things hot. Hey Mako, it's been a while since seen you. Hey hobbyist. Hello, goodbye. I guess, I don't know. Yes, so that's the plan. I think that's what I need to do, is build a charge circuitry for this thing to make it nice. You're just sitting way backing up behind us. Okay, no worries. Hey, it's fine. Hey, you're still hanging around. So yes, right, that's the plan. I have a plan. I have a way forward. And this is way more complicated than just dropping a battery pack in, wasn't it? I was expecting to do this. I thought I'd, spend 5 minutes, drop a battery pack in, hook it up, move on to something else. And where did that go? I was not expecting this. Yeah, exactly. Bad design. I'm really surprised by that. Yeah. I mean, the only thing I can think of is maybe the battery pack isn't just a battery pack, as I said. Maybe it's got some charge circuitry built into the battery pack, and that takes care of it. I would be surprised, though, based on what they've said about not overcharging it for more than 7 hours. I think they're purely relying on the battery pack dragging that current down and stressing everything. It's just, yeah, I'm really surprised. Why did they not have a 12 volt transformer? You know, why was that winding not 12 volts? Crazy. Absolutely crazy. Yeah, I'm just amazed by that design. It's almost like it's a transformer they had for something else and they just repurposed it. It's possible. Yeah, I'm pretty sure it's just NiCads. I don't think there's anything else on the battery, but it's just weird they've done such a weird voltage arrangement. You know, why would they have such a high voltage to charge such a small battery? I mean, obviously you want a decent charge current, but the system can't provide a high charge current. It can only shove in a quarter of an amp, right? So you don't need that voltage to do that. Just the battery wires, yeah, it's quite possible. NiCad battery. That's what it took. Yeah, incredible. So just to fill in the guys that have just arrived or weren't here before, I should say. This charging circuit, which I'm going to show you on camera, hold on, top screen, in case you haven't seen this already. So here's the main transformer. You've got two secondary windings. One is the main power supply winding, which runs the unit, and a second winding is to charge the battery, right, which is here. Yeah, I'll get a bit bigger for you. And it's a 6 volt battery by standard, right? This is what they designed it for, a 6 volt battery, which is fine. It runs with 6 volts. That works. We tested that. We verified that 6 volt will actually run it. But the voltage coming out this transformer here, when smoothed with a capacitor, is 37 volts DC. .37 volts DC when smoothed with a capacitor with no AC ripple anymore onto a 6 volt battery. That's just ludicrous. Yeah, so yeah, that's the problem I've been trying to figure out, is why was it so wrong? You know, to evaluate whether the circuit was actually wrong, whether it's miswired, or what, you know, what's actually here is this correct? And it all checks out. It looks like they have just designed this with a 37 volt power supply to charge a 6 volt battery. Oh, it's ridiculous. Anyway, it's been an interesting one. I mean, at least this has been an interesting stream, right? This has been not what I expected it to be. And that's a good thing. You know, I expected this to be a simple little drop a battery pack in, confirm the voltage is kind of, you know, near enough 6 volts. You know, I was expecting sort of 9 volts or so. I wasn't expecting 37 volts. You know, without the capacitor on there, without the capacitor on there, we're getting 24 volts DC with 11 volts AC ripple, because it's only half rectified. But with the capacitor on there, we're getting 37, which is what the battery would effectively be seeing. So, yeah, not good. Yeah, we already verified that, Josh. It's got one. I'm going to say it, Josh. It's got one switch, which you can just see top of the screen there. That is set to maximum voltage already, because we're 240 volts here, and that is in the correct switch position. So we're not running through on voltage. I've already verified that that is not wrong. So yeah, it's just crazy. It will run off 6 volts, yes. So the main power winding here, which normally runs it on AC, when you're running on AC power, right? It's running off this winding here. That is generating about 14 to 16 volts, depending on how loaded down the circuitry is. Right, so call it 14 volts minimum. And when you run off battery, it runs the same battery through the same circuitry. So here's a switch here, which is doing the power. That's switching the charging circuit. This is charging the power, switching the power. Right, so one side will come from here. Right, so this has got a common positive side. Right, so it's got negative side comes through here, and then this one here, when you go into this position, is charging off battery, and then you're coming from the battery pack, which is also joined to the positive rail. So you've got 6 volts across the supply or 14 volts across the supply, depending on which position you've got the switch in. So, yes. I'm just still stunned by this. It's just, why would they do it that way? It makes no sense. Yeah, no worries, Josh. It's alright. But yeah, that's it's just surprising that they designed it that way. It's just, I'm just stunned by that. I mean, it's a Keithley. It's a Keithley. It's a high quality unit, and they've designed it like that. I think it must purely be because they had this transformer already made and designed from some other project, can't say, like some other product, and they already had this transformer available to them, and they just put it in this unit because that's what they had available. And just thought, oh no, so I'll just tell people to not charge it for too long. It should be fine. What could possibly go wrong if you want to charge for 3 weeks? Oh. Oh, it's just a battery symbol. It doesn't really mean much. Yeah, don't take the actual symbol to heart as actually being only 3 cells. You know, it might have a 10-cell packet, it might only show 2 cells. I mean, don't worry about it. That doesn't actually mean anything. Not always. I see where you're coming from, but... yeah. Anyway. I need to look at this tomorrow and see what I can do to build something for this. Yeah. But at least I've got a route, but I don't have a 30 volt zener. I've got a 24 volt and a 6 volt zener sitting right there on the desk. I see a commonality here. Let's shove them in serials and see what happens. Let's shove this on here. Clip these two together. Let's just use this clip lead. I'm going to shove these up so it equals 30 volts instead of 24. So we've got a 6 volt zener and a 24 volt zener. Get everything ready. It's back in battery mode still. DC current. Power on. Turn it on. So at 30 volts we're getting 54 milliamps or so, dropping down. I could probably actually change which one of these ports I'm in actually. Let's do that. Let's shove this in the 400 milliamp. Chuck it on there. What do you think about lead? I don't know. DC, turn it back on. So with 30 volts of zener, we're getting about 50 milliamps across there and dropping as they're warming up. Or it could be as the resistor is heating up, because that would be dropping extra voltage through it as it heats up. So it looks like it's stabilising about there. So my estimate of 50 milliamps was on the money. Not bad, is it? That was a good guess. So how hot are these zeners getting? That's fine. Barely warm. Actually, no, that one's hotter. That one's hotter. That one's not too bad. This one's hotter. Obviously because it's different loads, because one's lower voltage than the other, so one is dropping very little and the other one's still dropping a fair bit. But it's better than it was. I could always use like 215 volt zeners instead to even it out. But that's looking promising. 50 milliamps just to the zeners, and that's going to take a bit of current stress off it, and that's limiting the current quite nicely. I may better use a different voltage setup. I don't know. I might have to look at this, but yeah, I'm going to limit the current anyway for the charge circuit, so it should be okay. I was starting to put too much stress on the rest of the circuitry because I'm mindful of those two little diodes in there. we're getting hot on 250 milliamps. So definitely want to keep the current low. So this is 50 milliamps just for the zeners. Then I also need no more than 50 milliamps to go from the regulator and the charge circuit to the battery. So if I limit, if I build the current regulator to be for 50 milliamps, that should then be no more than 100 milliamps for the whole circuit, hopefully. Because you use a little bit in the regulator, but not much. Yeah, that's the plan. Unplug that from that one, plug it back into there before I forget, and blow the fuse out. Never done that before. Yeah, I was recording, it's fine. You're thinking lead acid? Oh, right, okay. Well, the manual states NiCad, so... I mean, 6 volts would have been a good lead acid battery's voltage. But imagine doing a little lead acid battery in there, and having that thing potentially charged at 37 volts. I think it might start boiling. Yeah, so I mean, I'm still wasting that 50 milliamps for the zeners, but I think that needs to be done for that resistor. Or do I add another resistor to create a larger voltage drop and increase the power dissipation? Yeah. No, I think I've got my plan. I've got my plan. I'm going to stick my plan. I think that was going to work. 30 volt zeners, or 30 volts of zeners, voltage regulator, current regulator to the battery, and that should then be okay. I mean, I can adjust the current regulator as well, because, like I said, I'm not worried about charge current. I'm not worried about that at all. So I'm fairly happy having a low current to charge the batteries up. That doesn't bother me. But it will make it safe. It means it's not going to be destroyed by leaving it plugged in. I'm not going to have the thing exploding batteries inside it, because that would be awful. Could do all sorts of damage. Now the next question is, do I have a 7909 regulator? 7909 regulator, do I have one? I don't know if I do or not. I may have. I think I have bought them in the past, so I probably do have some in here. I'll look at that tomorrow. I'll look at that tomorrow and build it up. Yeah. It's a project for tomorrow. And I can add it onto the actual video when I do the actual video production and show that. And then I was thinking I was going to have trouble getting enough content to make a decent video out of it to make a published edited video. And this has really not been the case. I've got probably way too much video to recorded, which I now need to try and edit down, I think, to make a sensible, coherent video, which could be tricky. Yeah, I think that's the way to go. So I can't charge more than 9 volts. I mean, I could potentially bump it up a little bit more. I could go 9.6 volts, because if I have a 7909 regulator, depends on what the tolerance is as well. Sometimes those regulators don't have a great tolerance. It could be half a volt up and down. I think that's the limit, something like that. It can be quite loose in the tolerance. Maybe it's 0.3 or 0.4 volts difference. I can't remember now. So it might be that is slightly above 9 volts anyway. I'd have to see what it ends up being, but another way to say, as I said before, is to shift the regulator voltage. If you need to shift it like half a volt or 0.6 of a volt, stick a diode in there in the negative reference line, so the ground line. You put it in there and it'll shift the voltage by that much, because it uses the negative of a positive regulator, at least. It uses the negative as a reference. So if you shift it by half a volt, or by sticking a diode in there, the whole voltage will shift by that much. LM317T, that's also possible. But isn't that only a positive regulator? Is there a negative version? I think I've got some LM317s, but I don't think I've got any negative versions. I didn't know there. What's the code for that one? There is a T negative version. I think I've got some LM317s. Pretty sure I've got some. One or two. Yeah, Siglent diode reference pin. Yeah, that's right. It's a nice little thing. If you need to just tweak the voltage slightly, it's really handy. I've done it multiple times in the past. .337. Ah, that sounds right. Yes. LM337. I think that's right. Yes, that sounds right. Let me quick look. Come on, where does it say which polarity it is? There we go. LM337, 1.5 amp negative adjustable voltage regulator. Yes. Don't they go to 40 volts as well? This is from AliExpress, not quite the one I want. Hold on, let me just I might even have a data sheet for this already in my files. Let me have a look. Technically it's integrated circuits, I need to look in there. Integrated circuits. LM. I've only got 317, I don't have the 337 listed in there. I'll have to get that one, but it'll be the equivalent one. So maximum input voltage is, it says maximum output is 37, so I'm guessing it means it must be more than that. You know, you think so anyway. Where does it say it? Come on. Why doesn't it say what the... Surely it must say what the maximum input voltage is. I must have missed it. I think it's about 40 volts memory. So if I've got a negative one, that could save a step with the zener. There we go. I went past it. 40 volts max. Input reference differential voltage is 40 volts. And I think the reference voltage is about 1.2 volts or something. So is that 41 volts max? So that might be fine. I might not need to use a zener, which will save a little bit of current draw. So I can use an LM337T with a current regulator and limit the current with that. It's going to give me much less wastage. That would be significantly better. Series of 220, yeah, okay, yeah. That's what I thought it was, yeah, I wasn't sure. I was just trying to figure out what the negative version, because I knew the 317 was the positive version. Yeah, so 337 is the negative version. I don't think I've got any of those. That's the only problem. Now I need to look through here. Let's try and get some more lighting. That's as low as it goes. They're breaking it off the shelf. Damn, I can't see a damn thing over here. My eyesight's not what it was. 7915. And I've got like a tray of regulators in here, which aren't 788 series. Not 78 series. Got other 78s in their own drawers, and other 79s in their own drawers. This is like a random one, which is like all sorts of other stuff. 7905, I think that was. These are some 5-pin ones. These are special ones. M340. That's a 7815. Yes, I'm not liking my chances of having a 337. Another 340 there. Yeah, it'd be nice if I had a 337. I don't think I do. Not all these parts in my website. I can't say it. The website I have, which is called mypartsbin.com. I don't have all of my parts listed on it yet. So things like this, which have got a big like arrangement, sort of assorted bits and pieces, they haven't necessarily been put in there. So I don't think these have been put in. They could have been, actually. Maybe I should check. I'm assuming I haven't done it. There could be a mistake. Look, I've got a 317. There's another 317. We're not quite there, are we? Yeah, I'm not liking the chances here. I don't remember having any 337s. Go look at my website just to make sure, just in case I do actually have one listed in there somewhere and I don't realise I've done it. It's possible. My memory is not like it used to be. I used to remember so much stuff. I used to remember every little detail about everything. Every little thing I ever worked on, every repair I ever did, every fault I ever found, every rectification I ever did for every fault I ever found. I can remember every little detail. Now, I don't know what I did last week. Or even yesterday half the time. Anyway, let's go to my parts bin and see if I've got it listed as having a 337 in there. Let's just check it. Yeah, I'll even show you what I'm doing. How's that? I'll drop it up there. Oh, will that mess up the bloody dragging windows between screens? Yeah, there's my site there. I should really do a new logo for this thing. I'll just throw that together quickly to have a logo. It's supposed to be a parts drawer. I can't draw for hell. Anyway, still search for 337. Nah. 317. Yeah, so we've got 317, but I don't have any 337s. So yeah, no good there. Yeah, I know you can do constant current supplies with a regulator like that, but I actually have a constant current regulator board which I designed, which I was thinking I could use that because I can adjust it quite easily with that. Constant current, that feeds back from the output, doesn't it? How does that work? It's the reference pin goes across the resistor, which is in series with the output. Wasn't that how those ones are done? You're 37. Just wait, give it another 10 years, man. Yeah. So yeah, I don't have that bloody part. That's annoying. Yeah, I mean I've got all these other parts. This sort of stuff I have logged in there yet. Well, so far. And there's loads I haven't put in. There's loads and loads which I have not put in here yet. There's a bit of a discipline trying to use it. Anyway. $50, 25, yeah. I don't know. Your memory seems fine here. Seems to be anyway. You do all right. Yeah, so that's what I'm thinking of. That could be another way of doing it, is to simplify using the regulator as a current regulator rather than just as a regulator, and limit the current. But then I've still got the issue where I still want to regulate the voltage. So I still need a voltage regulator. Maybe I need two 79 series. Maybe I could use two 79s. One as a voltage regulator, one as a current regulator, and simplify that. That could be done instead of using my board. I mean, I could put my board in there, but it's a bit more complicated, and it's probably overkill, really. Yes, that's what I remember. I've never actually done it. I've seen it, and that's what I remember it being is a series resistor, and you put the reference on the other side of the resistor, and so you can then current regulate based on that voltage drop across the resistor. So because it's measuring the voltage drop, then you're regulating the current. Yeah, something like that. Anyway. Anyway, yes. So unfortunately I don't have a 337 here, so I don't have one, so I can't just sit down and build that tomorrow. Which leaves me with a 7909. Oh wait, did I actually have a 7909? I'm assuming I've got one. I think I do. Let me check my parts bin, which I just closed. That looks like a no. Do I have 788? I don't. Maybe they're not in here. It could be they're not actually listed in. Maybe I've not added them in. I know I've got 7815s. I saw those. So I definitely saw those and they're in there. So yeah, 7909 is unusual. It looks like I haven't got those either. Oh. Just when I thought I had every part I could ever possibly need, seems I don't. I do have giant balls, but the chance of having the right parts are unlikely. I do have some stuff, but I don't think those kinds of parts are beyond them. Oh, actually, maybe. There's some things which I got from work which I intended to do videos on. They might have those in. It's possible. It's like old computer modules, like big machine control screens, which actually work. It's possible that it might have some in there. It would be a shame to rob it out there before I've done a video on it, though. Right, I need to buy some more parts then. I guess I might book this tomorrow after all. That's annoying. Okay, I'm going to buy some regulators. Let's make a note of this. LM337T 7909. Need some of them. 7908 and some of them. I'll add them to my list of things to buy. I've actually got a list which is already partially done on element 14 of things I need to buy, so I'll add those to that list. Hopefully they got them, and that could be a week or two before they turn up, maybe longer, which is okay, I suppose. This delays this project a little bit. I'll get a bunch of those, and there's some other things I want to work on, but I was kind of delaying doing the order until I worked on these other things because I wanted to see what capacitors I need to buy, because now I've got these other bits of gear which will need caps. But I don't know what caps I need yet, and whether I've got them here, because there could be some quite large ones, which are main power supply, smoothing caps, stuff like that. So I don't have any particularly big ones. I've got all the common smallish sizes like 4,700 downwards. Maybe some 10s, I might have some 10,000s. But yeah, it's likely I'm going to need some bigger ones for these devices, which I don't normally have. So I was kind of holding off doing it older until I knew whether I needed those or not. Anyway. Right, well, that's that. Yeah. Was it a disastrous live stream because we haven't achieved anything? Well, we have achieved something. We figured it out. We know what we need to do. We've actually got a plan, and you know, it's. I suppose I've achieved something, but I didn't achieve what I wanted to do, which is to put a battery in it. Something as simple as putting a battery in it will turn into being a 3-hour ordeal of trying to figure it out and sorting out why it's not right. Hey, John. Yeah, I'm just wrapping it up, John, I think, because I've been streaming for a few hours now. And we got to the point where we're not able to do any more on this particular project tonight. It is what it is. I need to get some more parts before I can finish this one. Yes. Yeah, New Zealand's alright, can't complain. Pretty happy. Weather's a bit wet. It's not very cold though, because it's winter. It doesn't actually get that cold. But it's been raining a lot recently. So everything's a bit wet and soggy. As it is. But can't really complain, it's pretty good. It's relatively mild. I mean, winters here are very mild. That's one of the good things about it. Yeah, the further south you go, the colder it gets. In winter, it dips down to lower levels. I used to live in Tauranga. Oh, okay. Is that Tauranga or Turaga? I don't know. Is Turaga? I'm not familiar. I guess you mean Tauranga. Guess you missed the ear now. Yeah. No -7 yet. Yeah, no, it can get pretty cold down there. Only -3, yeah. It normally only where I am doesn't normally get that cold. I think the coldest I've seen it right where I am, probably in the past 15 years, so it's probably been like -2s. Or it's the coldest I've seen it get to, and that was only for like in the morning, and then it's up to like 4 degrees, something like that, pretty quickly. It doesn't get that cold here. It's usually, you know, in winter it's usually around 4 degrees or so in the mornings. That kind of temperature. It's not usually that cold where I am. It's pretty good. Might get your day where it goes down to 0 sort of thing, but not much. Anyway, waffling on, talking about weather. It's an electronics channel, for God's sake. God's sake. 4 and 7, yeah. It's just for a short time, then it comes back up again pretty quickly. Right. It's not a weather channel, it's an electronics channel. Completely off topic. Okay, we'll wrap this up. I'm going to get a coffee before I go to bed, I think, because I'm pretty thirsty now. We're talking. And it is 11:30. Well, you'll know that, Josh, but other people may not. Yes, I've got a plan. I'm going to... Actually, before I go to bed, I'll do this order. I'll get these parts ordered. That might get my day earlier, maybe. Yes, I'll order these parts. And then I'll go to bed, I think. So thanks for dropping by. Give us a thumbs up before you leave if you found it interesting. I found it interesting, and I don't know what the hell I'm doing. Yeah, that was interesting. I think that was pretty good, actually. That was pretty cool. So, I'll catch you later, and I'll do another live stream at some point. I'm not sure when yet. I don't have a lot on for a few weekends. It's possible I could do another one fairly soon if the parts turn up fairly quickly. Maybe when the parts turn up, I'll do another stream once I've figured it out and got it actually built. I might just build it up on a breadboard or something and test it out, and then we'll build it and do it as part of a stream maybe. The wife is back. We'll have to go and pick up from the airport in 2 days' time. So, yeah, she comes back on Tuesday. So she actually flies out for you tonight. So she flies out at 10 o'clock tonight, I think it was, something like that. So, so it takes that long for her to get back. It's like 36 hours in time frame or something. I don't know. It's a weird bloody time frame, but it's 10 o'clock for you tonight because it's like 12 hours, well, 9 hours time for you, isn't it? From now. Then it's like 24 hours or so of flying, wherever it may be. So, yeah. Okay. So, yeah, she's almost left the country. Almost free of her. That sounds a bit mean, doesn't it? That's not right. She's a lovely person. Okay. Catch you later. I'm waffling on now. Just go.